गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि।
Please play the national anthem and they must come. Now, I request Honorable Vice Chancellor Sir to present the welcome address and to preside over the function to conduct the festivities.
Good morning to all. The chief guest of the today's function, Dr. Prakash Chauhan, and other dignitaries on the days, Dr. C.H. Mohan, Chairman, Scientific Advisory Council, SAT, ASTC, and former Director, CCAP, Dr. T. Swarnandhra, Founder Director, Homi Baba Cancer Hospital, Dr. Ahmad Kamal, KNR Prime Minister Chair and former outstanding scientist of IICT, Dr. Sridevi Annapurna Singh, former Director, CSR, CFTRI Mysore, Dr. C.S. Srinivas Garu, Director, IRI, ICAR, New Delhi, Dr. S. Venkat Garu, Director, CSR, Neri, Nagapur, and my, Asma Garu, and then the Subara Garu, Devi Ramana Garu, my colleagues of the dais, Professor P. Subara, Professor M.H.M. Krishna Prasad, the various invitees, distinguished guests, faculty members, and research scholars of this university. I welcome you all to this 2 days conclave, actually 2+1 day conclave on the technology. The genesis of this conclave is, we all know that based on the Pokhran test in 1998, India is celebrating the 11th May as the National Technology Day every year. So last year, we have celebrated this with the Research Scholars Symposium.
Yeah.
At JNT Canada, we have over 1,000 scholars, both full-time as well as part-time. Most of these scholars are working somewhere as a faculty members, and there might be full-time scholars also. We thought that we have to create a platform for these scholars to compare themselves, the quality of work with the other scholars, and also giving a platform for them to interact with the scholars working at different districts, because JNU Kakinada is spread over, the jurisdiction is spread over about 13 districts. So they might be working in different locations. They may not be knowing who are the people who are working in the similar areas. We thought that giving a platform for them, interacting with each other, they knowing what the works are being carried out by other scholars, and also comparing their work with other scholars' work, they might be knowing where they stand, what the quality of work, etc. In the process, it will motivate them to do a good work. It will also motivate them fine-tune their line of research. So this time, what we thought is that alone may not be sufficient. They should be exposed to the innovative ideas and the better ideas. So then we added 2 more days, 9th and 10th, is conducting a technology conclave. Even though we named it as a technology conclave, Swarnandhra, which is Bharat 2047, maybe that might be the ultimate goal. But my immediate goal and my selfish motive is my scholars should be exposed to the hearings or the expert talks by the eminent persons. I have to thank from my bottom of heart all the galaxy of experts sitting on the desk. It's not easy to bring them to Kakinada. You know that it's not a well-connected city, unless otherwise we depend on the Rajahmundry airport. And those who are coming by train, they have to get on at Samalkot Junction and coming all the way to Kakinada. So some of them might be visiting first time the Kakinada. I think I have to thank Madam, even though she is Kakinada is our native place. I think after 45 years, she is visiting the Kakinada city. That's what led that. So I have to thank each and every one of them, especially during the summer. Travel is not easy, and out of their love and affection towards the science and technology, they're kind enough to accepting our invitation and visiting the campus. So the idea is, they're all the eminent persons. They are the who's who in their respective areas. They reached their pinnacle in their research community, and they have contributed a lot for the advancement of the science and technology in this country. So these people, they are going to give us the technological changes happening, present, past, as well as the future, how the technology is going and the direction. Probably this will motivate myself. That's my selfish interest. This will motivate our research scholars and for a course correction of their thesis work also, and also fine tune their thesis work. So in the process, the quality of research work will go up. This is the idea with which we are conducting this technology conclave. So most of the participants, more than 90-95% of the participants are the research scholars, are part-time or full-time. Some of the faculty members and faculty members are also there. Probably you might be seeing the gray hair like Professor K.V. Rao, and even though he's 80 years old, but he's very young at heart. He is much active and faster than many of the young people also. And Professor Ramakrishna is also here. He is also another young boy with 8 years old, but still he is going strong. Many times I feel ashamed of myself by seeing those two great persons in the campus, and I'm not able to work even 10%, 20% of the energy levels of those two people. So we have a scholars here. I request all the scholars to be more attentive and also interact with these people. It's difficult to get their interaction also if you go and meet them, try to meet them in their offices, because taking 5 minutes, 10 minutes of time, their finish it is also difficult. Now they are here. So please interact. First of all, be attentive when they're there with the talk. Note down the points, important points. Definitely they will help you in carrying out our research and also improve the quality of your research work. Then during the tea breaks or the lunch breaks, when they are here, please interact with them. And if you have some doubts, you get the clarifications. With these few words, once again, I thank all the experts coming all the way, and especially I have to thank Narasimha for last 1 month, and he's dedicated for this technology conclave, interacting, coordinating, and planning this particular activity along with my professor M.H.M. Krishna Prasad. So I also appreciate the M.H.M. Krishna Prasad and his team for making all efforts to making this event realistic. So I also thank all the scholars who have taken their time and coming all the way from the different parts of the state for attending this workshop. I hope this workshop or the conclave will be the most fruitful and beneficial to one another. Thank you, one another.
Thank you, sir. Now I request Dr. K.V. Ramana, Secretary, AP Space Tech Academy, please come on to the dais, knocked by the chair. And also, sir, I request you to Dr. K.V. Ramana, we request you to discuss about the APSA. Please come on.
So please, sir.
Yeah, good morning to all of you. First, my sincere apologies to all of you for delayed arrival for this program. And it's my duty to thank our distinguished guests, chief guest and distinguished guests for coming all over from various places, especially Dr. Prakash Chauhanji, Director NRSC, Mohan Raukar, and other distinguished speakers and guests. On behalf of AP Space Tech Academy, I would like to thank once again. And regarding the AP Space Tech Academy, this academy is formed in October 2025 on the day of National Space Day, and it is designed to bridge the gap between the academic research and the demand for the emerging global space economy. And its vision is to establish AP as a hub of excellence in space science and technology, nurturing skilled talent, fostering innovation, and driving the sustainable space ecosystem. The need for formation of this body is, if you look at the national and international scenario, global scenario, about in 2023, the total value of the global ecosystem, space ecosystem is around 630 billions. And while that of India is only 2%, coming to about 12 billions. And considering our importance to the aerospace and defense sector, our Honorable Prime Minister has liberalized the space sector to the private entities. And they have, unlike earlier agencies, international or national agencies, where only governments used to build and launch the satellites. Now this policy is made free. Everyone, any private entity, non-government entity, they can build their satellites of their choice, launch, and then market. And that's how we make them useful for the society as well as the capital building of the nation. And coming to the AP scenario, AP is the first state to form the space policy in our country, and it has committed to development of 2 space cities, one in Lepakshi and the other one is in Tirupati. And keeping these particular 2 points in view and the international projected scenario of about 1.4 trillion economy, we also can have a check of this for our whether it is from India or AP. So basically, this requires not only hardware, we require the people, that is the soft skills of the people. So in order to bridge this gap and also make the students of Andhra Pradesh better leaders in the space ecosystem, this academy has been formed. And it's basically driving on three pillars. One is outreach activities, the second one is skill building, and the third one is fostering the mentorship. And outreach activities, we have conducted 4 activities in the last year, and one mega event at Vijnan University, that is the AP Space Tech Summit, along with the rocketry challenge for the entire South India. And coming to the mentorship, we have a very seniors who have retired from ISRO and other national centers in all the fields, starting from the rocketry sciences, satellite systems, applications to life sciences also, space life, space biology, and they can mentor the startups if anyone requires any initial knowledge and all. So this is how the Space Academy is trying to serve the state of Andhra Pradesh, and it is in the first year of formation, and still some initial these things are there. Maybe by shortly we'll welcome all the official formalities, and this body has also launched a quarterly journal called Space Tech Spectrum, and you are all requested to submit your review research papers and all. And with this, I thank the Honorable Vice Chancellor Prasad Garu for accepting our joint request from the Academy of Science, Technology, Communication as well as the AP Space Tech Academy for hosting this technology conclave. I thank you, university officials, sir, and especially Narasimha Garu for driving this conduct of this program. And thank you one and all.
Thank you, sir, Ramana, for explaining about the APSC activities and introduction of journal. Inviting the scholars to submit paper. Thank you. Now, I request to see CL Narasimha, Secretary, Academy for Science, Technology and Communication, to mention about the ASTC activities and introducing the guests.
Good morning, it gives me immense pleasure on behalf of the Academy for Science, Technology and Communication. So warmly welcome all the distinguished scientists, technologists, clinicians, and faculty members, research scholars, and media representatives to this technology conclave for Andhra Pradesh and Vikasit Bharat, being organized by the Jawaharlal Nehru Technological University, Karnataka, around this ASTC and the ASTC Space Tech Academy as knowledge partner. Coming to about the ASTC activities, the ASTC was founded in the year 2004 with the blessing of Dr. K.V. Bharat, the former distinguished engineer and former director of IACT and former chairman of the RAC DRDO. This academy is committed to promoting scientific campus, strengthening science communication, and advancing science and technology for societal benefit and national development. Over the years, ASTC has organized numerous public lectures, seminars, science conclaves, parent discussions, and outreach programs, with continuously encouraging young scientists, talent, and interdisciplinary progress. Today, ASTC has joined an effort of about 150 honorary fellows, actively contributed towards science and technology initiatives. Coming briefly about the major activities, during the past year, the ASTC organized several important national activities, right from the National Technology Day of the last year. These celebrations were held at Hyderabad in April 2025, inaugurated by the then Honorable Governor of Telangana, Sri Krishnadeva Verma. Contribution that pre-Nageswara, Chairman of the Institute of Judgment of the delivered the foundation day. The ASTC has also celebrated the Space Day just now from on 22nd August 2025 at Vijnan University, which laid the foundation for the formation of the Andhra Pradesh Space Tech Academy under the presidency of Dr. Paul Subbarao, Chairman and Managing Director of the Andhra Technology. As part of centenary celebrations of Andhra University, the ASTC organized a science conclave Science Technology Frontiers for Swarnandhra and Vikasit Bharat to introduce to Bharat Ratna Radhakrishnan with the initiatives of T.C. Rajshekar, the Vice Chancellor of Andhra University. Next, Sri Ravi Venkanath, former 13th Vice President of India, inaugurated the JHCC National Conclave Lab to Society Science Communication for Vikasit Bharat on 8 January 2026, recently at Hyderabad, jointly organized by Enadu Group and North Hyderabad chapter. Dr. Samya Swaminathan, chairman of the MS Swaminathan Research Foundation, delivered the foundation lecture and the keynote speaker. Subsequently, the Academy also organized the National Defense Science Conclave on 6th February in memory of Professor Bhagavantam, former scientific advisor at NRIT, Vijayawada, inaugurated by Dr. V.K. Saraswat and attended by directors of Defense Laboratory. Coming to strengthen the science communication and public outreach activity, AICC launched the publication series as AICC Communication, covering important contemporary scientific insights, including cancer awareness, nuclear power, clean energy, gas ideas, and solar energy. The Scientific Advisory Council of AICC continues to guide the academic vision and strategy. It is my privilege to extend a warm welcome to all our distinguished dignitaries and invited guests. Dr. C. Swarnandhra, Chairman of the Scientific Advisory Council of AICC, the distinguished molecular biologist, former Director of CCMD, recipient of Chancellor Karnataka Prize, and currently Chairman of the National Academy of Sciences, Telangana chapter, and President of the Telangana Academy. Dr. D. Raghunatha Garu, a pioneering medical oncologist, former head of medical oncology at INS and Nizam Institute of Medical Sciences, a visionary leader in cancer care, research and prevention. He played a key role in establishing Tata Memorial Cancer Hospital at Visakhapatnam under the Department of Atomic Energy. Dr. Ravi is also recipient of the prestigious B.C. Roy National Award and is also president of the Andhra Pradesh Academy of Sciences. Dr. Professor C.S. Satya Prasad, Vice Chancellor and the District Academician, with major contributions in transportation engineering, research and institutional leadership experience, with more than 3 decades of teaching. I sincerely thank you as you were instrumental in organizing this conclave in this campus. Our chief guest, it is my pleasure to, it is my great honor to welcome the esteemed chief guest, Dr. Prakash Chauhan, Director of the National Remote Sensing Center, ISRO, a distinguished scientist in remote sensing, planetary sciences, and Earth observation application. Dr. Chauhan has made pioneering contributions to lunar science through Chandrayaan missions, including landmark work related to the detection of water molecules on the moon surface. He also serves as important international scientific leadership roles, including at the United Nations Committee on the Peaceful Use of Outer Space. We are deeply grateful to Dr. Prakash Chauhan for graciously accepting our invitation despite his very busy schedule. We also congratulate him on the recently taking additional charge of the as the Director of the National Atmospheric Research Laboratory at Tirupati just a few days back, and wish him many more achievements in the days to come. AICC extends its grateful thanks for his kind participations with encouragement and constant support to the cause of advancement of science and technology. We are honored by the presence of the several Indian scientists participating in this conclave. Dr. Ahmad Kamal, Ansandhan National Research Foundation Prime Minister Professor, and a renowned pioneering person for pioneering contributions in drug discovery and pharmaceutical science. Former Director of CSR IICT and the founding Director of NIPER Hyderabad. His pioneering research in medical chemistry has led to the globally recognized innovations and in anti-cancer drug discovery. He has over 580 publications. He will enlighten us and in his distinguished lecture in memory of Dr. K. Anjali, the founder of Reddy Laboratories and also past president of the JP Academy of Science. Dr. C. Srinath, Director and Vice Chancellor of the Indian Integrated Research Institute is going to join in the afternoon. He will be delivering his lecture in memory of Dr. M.S. Swarnandhra and Dr. Sridevi Sarvana Singh, former director of PSR, CFTRA, and a teaching scientist known for his contributions in food science, nutrition, and functional food. He has made significant contributions in protein chemistry, nutrition, food technology for combating malnutrition, sustainable nutrition interventions, with several technologies transferred to industry and public health programs. We will be delivering this next lecture focusing on food technologies and functional food. Dr. S. Mohan Garu, Director of KSR Miri, recipient of the Constitutional Personal Award, and one of India's leading environmental scientists, recipient of the prestigious Vijnan Sri Honor from the Honorable President of India recently. He has published more than 450 research papers on 36,000 citations and research in several states. They will be delivering the distinguished lecture in memory of Padma-Shri Dr. Bharat Naidu, a distinguished leather technologist and also former president of the Andhra Pradesh Academy of Science. We also warmly welcome our invited speakers for this special technical session, including Dr. Kalakan Sanji, internationally acclaimed geophysics and former director of the Vadia Institute of Himalayan Geology, who will pioneer in contribution with the seismic tomography, machine learning in geosciences, geothermal energy, gas hydrates, geohazard studies. He has authored over 350 scientific works and 12 research. Professor Dr. T. Harinarayana, a distinguished renewable energy expert and director of JESMI. His contributions to earth sciences, renewable energy, particularly solar energy and national scientific development are deeply appreciated. Tomorrow we are having Dr. B. Venkatraman, distinguished nuclear scientist, former director of IDCAR. He will be delivering Padma Bhushan Dr. A.S. Rao, founder of ACL, in memory of Padma Bhushan Dr. A.S. Rao, founder of ECL. So, this is Dr. Professor D.P. Rai Secretary, Vice Chancellor of Andhra University. He will be speaking on mathematical modeling. And Dr. C. Natchandra, Vice Chancellor of the Venkateswara University. He will be delivering initial lecture on material science. On behalf of the Academy for Science, Technology and Communication and all organized partners, I extend my heartfelt gratitude to our speakers, teaching scientists, invited speakers, former vice chancellors, and all academicians who have served director centers from, and particularly research students from all affiliated colleges of the training teams. I welcome you all and media representatives and organizing committee for their valuable presence and support. We are confident that today's deliberations will inspire young minds who are research scholars here, strengthen scientific collaboration, and contribute meaningfully towards the vision of Swarnandhra Pradesh and the spiritual path. I will please conclave with that. I grateful. Thank you.
Thank you, sir. Sri C.L. Nagpur. Now it's time to listen the messages of our guest of honor. I sincerely request Dr. C.H. Mohan, Chairman, Scientific Advisory Council, SAC, ASTC, and the former Director of CCMB, to address the participants. Thank you.
Sir, Prasad, Vice Chancellor of JSPU, and Prakash Chawla, Director at NRSA, and many of my colleagues, most of them are my friends. We have been sharing the diaspora on many occasions, and all of them are very, very distinguished people. It's not that they are directors of institution, they are also the people who have made significant contribution to science and technology. And I really congratulate JNU, JTU, and also APSA and ASTC for taking this conclave and organizing this with so many outstanding people. Of course, I would have liked large number of engineering students and college students also to come here and participate and get the benefit out of these interactions. As you all know, about 52 years ago, in 1974, India tested first nuclear device. That is 1974 on May 18th. And after about 24 years after that, 1998 on 11th May, India tested another nuclear device. This time there were 5 devices. This was called Operation Shakti. The first one was Smiling Buddha. Buddha just started smiling in the 1974, and in 1998, this was a major event where the Operation Shakti was conducted, and the world India demonstrated to the world Indian capability and as well as deterrent for the rest of the world. This event started a lot of technological advances in the country. In addition to technology advances, one thing very striking and promising is that Abdul Kalam and other people who organized the second event could manage that secrecy. Secrecy of the event was fantastic. Nobody in the world, including CIA, nobody in the world knew until the explosion took place. That secrecy maintaining in our country is next to impossible. Any conferences, any selection committee meeting happens before the results are announced, everybody knows about it. That's a standard practice of our country. But managing that was a fabulous thing that they have done, and technology advances so well. Now you know that we have fast builder nuclear reactor has gone critical. If this is successful, and then we also go to next step, then India doesn't have to depend on anybody for energy requirements. So that is the greatest achievement very soon is going to happen. All this was initiated, essentially started by Homi Bhabha. Homi Bhabha first started TIFR, Tata Institute of Fundamental Research or Physics Research, then started BARC. It was not BARC at the time, because Atomic Energy Establishment, PET, that was the first established. After he passed away, it is called BARC, Bhabha Center. I wanted to tell the younger students, particularly engineering students here, what Homi Bhabha wrote to his father. Homi Bhabha's father was a businessman with a very large money, people with a lot of money. They all wanted their children to study engineering or medicine. In Andhra Pradesh and in Telangana, everybody wants to become a medical doctor or an engineer. Nothing else is left for them. Now, his father also wanted Homi Bhabha to become an engineer. He wrote to his father saying that I am not going to become an engineer. I don't want to become an engineer. Physics is in my heart. I want to learn physics. I want to make major contribution to physics, and he chose physics. This shows how you are committed, you are dedicated, you have passion for a subject. That is more important than which gives you high package. Now, the parents and children are just getting into rat race of packages and things like that. They essentially fail. Parents says they will get a job, leave all the money for a few years, and that's end of their life. If you want to make a significant contribution, make your life worthwhile, then you should choose what you actually like, where your passion is. And that's what we Bhabha did. And his passion, now you can see how the whole country is getting improved. So this is very important for the people. Thinking of that, and since that I'm coming to engineering institution, I thought I will talk to the engineering students about why they should know science, biology, but in particular biology as well, because there is an understanding, there is some thinking that the engineering people only need to know engineering, they don't have to know any other science subject. There is a debate now going on to discontinue or decrease the chemistry, physics, and biology teaching for engineering students. I think this is wrong. So we were making a case everywhere. So that's why I wanted to talk to the students about what's the importance of biology in engineering. That takes us to even quantum computation. Today we are talking about quantum computation. Biology can teach you how to do quantum computation. So this is important. I would be addressing that in the later part of the session. I really close this now. Congratulating once again JNTU, APSA, and ASTC for thinking of this project, this problem, this conference, and organizing it, and with a large number of intellectuals on one side and research scholars and faculty here. And I hope that these 2 days will be very useful for everyone who will participate. And at least some percentage of people will get inspired and do much better than what they were otherwise thinking of it. Thank you, all the best.
Thank you, sir. Mohan Rao. Now, I request Dr. D. Raghunath Rao, Founder Director, Homi Baba Cancer Hospital, to address the forum.
Good morning. I promised him that I'll only spend 1 minute in the interest of time. My special interest is actually in clinical drug development. So you have a bright idea, either on the diagnostic side as a test or on the therapeutic side as an investigate a new drug. I can help you relate to the clinic, that is clinical market. So that is my special expertise. Of late, of course, I've also learned how to bring software as a device and software as a treatment, not just as a device, as a treatment to the clinic. So if any one of you as a scholar has some ambition to bring these to the clinic, you are always welcome to correspond with me or talk to me. Thank you very much.
Thank you, sir. Friends, starts with lecture is their keynote lecture at 12:10 p.m. He is going to address all around 40 minutes at that time. Now, I request Dr. Ahmad Kamalji, ANR Prime Minister says, and the father outstanding scientist IICT to address the call.
Very good morning to all of you. Johan. Previously on the dance and eminent personality in the audience, faculty of JTV and IMA students. I'll also be very brief because Monica was already given genesis of the technology. Why we are celebrating every year and during this period. I must say that this particular celebration is mostly an inspiration for the young scientists and was given by the younger faculty and researchers, so that we can come up with totally innovative aspects in science and technology. Although, if we see, India has been always working for self-reliance from the beginning. But the emphasis now has been given to become totally self-reliant. That's where I think the word has been defined as Atmanirbhar. And I would say that this is a very important aspect. As we all know, the research and technology innovations, what we can bring in, could bring a lot of good science. And we know how science is again related to our lifestyle as well as the economy of particularly a country. Because when we take an example of how the science could play a role,
the case of agriculture. It was Professor Swarnandhra who could bring a big change, a green revolution. So these are some specific examples. Similarly, another example of white revolution with a cooperative type of a lyric aspect. How such things have brought, I mean, these are all, let me say, in a way, some are very frugal type of a things, but these have played excellent results. And I must say, as again emphasized by the Honorable Vice Chancellor, that particularly the research scholars and the younger scientists, I would say that they should really try to explore something in the form of actual innovation in their research studies. And anyway, I'm going to talk later. So with these brief words, I would like to thank the organizing members, particularly the whole team of JNTU, who have played a great role to bring together, including the ASPC, where I think Ratna Simharao has been a very passionate person to hold such type of gatherings, and also to bring all the most eminent personalities who could contribute and also inspire the youngsters. So with this, I would like to thank everyone. Thank you so much.
Thank you, sir. Friends, Ahmad Kamal sir's session is today afternoon at 3:30 p.m. Okay, he's going to address on challenges in the design, discovery, and development of new cancer therapeutics. Now, it's time to invite Dr. Sridevi Annapurna Singh, Pharma Director, PSRI, CFTRI, Mysore, to address the party.
Dignitaries of the dais and of the dais, Andarki na namaskaram. I'm really truly feeling blessed today to be back in Kakinada. This is a town I spent most of my childhood. Unlike today's generation who goes on foreign trips or other places, there was only one place in the holidays, and that was the grandmother's house, which was on the Kakinada main road. Even as I got down in Rajahmundry and was traveling towards Kakinada, all kinds of memories came back to mind, whether it was Poli soda or Munjulu in the afternoon, the beautiful mangoes that you have, and so on. And also the beach where these red crabs, Peterlook were crawling all over the place. So thank you very much for this invite. I'm really enjoying coming back home, and happy to be with you all. I also feel it was a very necessary conclave, the technology conclave, because India aspires to be developed by 2047. And for any activity to be done, food is the basic need. All of us get up in the morning thinking that the breakfast is going to be good. So whether it is going to space or being on earth and living well, food is very, very important. The Indian context, if you take the food industry and allied industries, is around $535 US in billion. So it is a very important activity, and around 40% of our people depend on it for on agriculture for their livelihood. And we only process about 2 to 35%. 35% is dairy, otherwise fruit and vegetable only 2%. So there is huge scope for development because India is the number 1, 2, or 3 producer of food in the globe, but we are unable to value add to it. So in this context of Vikasit Bharat, definitely there is a huge relevance. Since I'll be talking later, I'll just tell you 2 stories and finish. The first one, because there are a lot of youngsters, you may not know this. I take you back to the end of World War II, and there was the Bengal famine in this country. somewhere between 2 to 3 million people died in Bengal, which was a huge number because there was no rice to feed them. All the rice that was produced in the country went to feed the British soldiers who were fighting in World War II. Then when India became independent, the government that was formed at that time decided that we have to extend the shelf life of food and also be able to transport it to far off places so that people will not starve and they will be able to get food. So there was a dearth of milk at that time, only buffalo milk was being produced in the country. And for infant food, only cow's milk was found suitable. And this was controlled by the multinationals like Nestle, GSK, and so on. And all of them refused. The reason is buffalo milk has more fat, it has more protein, which is not easily digestible by infants. So an institute was born in the country called CFTRI, and the first problem that was given to them was to convert buffalo milk to infant formula. And they started with how the milking was done because copper vessels were used at that time, which meant that once the 80 plus amount of water in milk is removed to make milk powder, the copper concentration would go up and that would be toxic to the babies. So they substituted the vessels with tin coating, removed the hay that was used for covering it and substituted it with lids, partially skimmed the fat which went into making of butter, and reduced the protein content by adding buffer salts and sugar. And that was dried, and this technology became a technology that was taken up by the Anand Milk Producers Union Limited, which is today known as Amul. So not only the food industry was born in the country, even the dairy industry took place. And I want to tell you this because that is the power of technology. Today, Amul is number one in many products, and it is a $1 trillion business today with so many livelihoods being created, and it has been a sterling example of Atmanirbharta of our country. A second example, all of us love sweets in our country. My personal favorite used to be gulab jamun. During my birthdays, my mother would get up at 6 o'clock and start making the kova from the milk. Somewhere around 3 in the afternoon, the jamun would be ready. Today, you would go into the market, just cut a packet, and within half an hour, you have gulab jamuns. Why I'm telling you this story, the scientist who wanted to work on convenience foods, when the problem was presented, the Research Advisory Council said, no, it won't work. And it's not fun, but he went ahead and did the work anyway. And today, nobody knows how to make gulab jamun directly from milk at all. So again, the power of technology. Now coming to Andhra Pradesh particularly, you have so many indigenous foods. My childhood was filled with Puralu, Arsalu, Puturekulu, and so on. But you don't see it in the market. They are only locally prepared and locally consumed. They deserve to have a global market, just like we know nachos or we know tacos or we know pizzas. Our food is no less. So you youngsters, please do look at these. Every CSR lab in this country started with a mega problem and they found a solution. So we ourselves have to find solutions so that we can create livelihoods. We can become not just 4 trillion, but maybe $40 trillion GDP by 2047. And there are a lot more you can do. Many underutilized grains and fruits and vegetables are present in particular regions, especially in Andhra. So please look at that, and I wish you all the very best. I'm sure this will bring out a lot of knowledge and a lot of new ideas. The conclave, I wish the conclave all the very best. Thank you.
Thank you, madam. We have seen the growth, development and importance of other technologies, including computer science and AI. So we wish to see the growth of technology now. Our Ramakrishna Rao, Professor Ramakrishna Rao garu is here and Dr. Jay Prasad. HOD is also there. Right. Now it's time to invite Dr. S. Venkat Mohan garu, Director CSIR NEERI, Oxford, to address the part.
Honorable Vice Chancellor, JNTU Kakinada, Chief Guest for this session, delegates, experts, on the dais and off the dais, faculty and my dear students, very good morning to all. First, I would like to thank organizers for giving me this opportunity. By long time, I want to come to this university, JNTU Kakinada. I visited all JNTUs. So I'm very happy to be here along with you today. So coming to the today's 2 days event, technology conclave, as Vice Chancellor told, is very innovative idea to keep all research scholars and faculty at one place from different disciplines and giving them the expert lectures as well as interactions with highly distinguished scientists. That will give a kind of awareness as well as vision, as well as some kind of ideas to reorient their research towards technology or towards the product or towards the process. So I would like to mention here a couple of points that technology is very important. When engineering students are doing their PhD, either coming with technology as a process or a product is very important. And at present, it is still important because throughout the globe, people are looking for some kind of innovations which will benefit the society. So coming to the technology again, technology should not be very elaborate. Like we cannot think that technology is very elaborate. It requires a lot of cost involved in developing. Not like that. So there's a frugal innovations, like when you are doing your research, you can identify some innovation. It will have a potential to go to the society. So that kind of things you can identify with your research, reorient from your research, and then you can work out on it. So for example, I would like to say, I'm coming from the Government Engineering Research Institute. We have near to 72 technologies on various domains of environment. So all those are not very high-end technologies, but those technologies was developed based on the need and with a less cost, which can be implemented in fields as and when required without much cost. So whatever we do, there will not much of cost is involved, but only idea and hard work that will matter. For example, at one point of time, we started working with a filter, very low cost filter, with a locally available material. So that is called NEERJ, which has contributed significantly during flooding and other places like throughout India, near to 2000 deployments has been done whenever there is a kind of rainfall event, disasters. So whenever water is not available, so Navy scientists go there and purchase local material with the local resources. They will try to make a filter by using the tablet, chlorine tablet, which will disinfect bacteria. But chlorine tablet was also a technology which was developed way back in 1968 by Navy. So now chlorine tablets are being in all ETPs or STPs at the final stage. So that innovation with the local stand, local stores helped us, helped in many instances. Recently in Jammu and Kashmir, near to 2,500 units were deployed in community level with a locally available material only. That's the frugal innovations, but still have a value whenever it is required. And normally we will try to give that technology free of cost. Anybody want to implement. Likewise, there are also technologies which can be developed with a simple idea, but have a lot of applications at very higher levels. So for an example, we know that there are contaminated labs, but for that understanding the contaminant and identifying the plant of microorganism will play an important role, and how to give the plant to growing conditions, and adding the nutrients is an important entity here. So likewise, with a simple this technique, Niri has so far regenerated near to 2,500 acres of contaminated land with simple bamboo plantation and waste organic material present. So what I would like to say, these are the very frugal kind of innovations, very simple ideas which have long consequence. So I would request you all to look into your research where you can find some kind of innovation that will have a very good chance of applying to the society, which can go for a lot of masses. So technology will not always a very big one. Technology will start from lab with an idea, with proof of concept, can go to any level. So here I would like to stop, and I will also like to thank organizers, particularly JNQ, Kumar Rao garu, for giving me the opportunity to share some of you with you. Thank you.
Thank you, sir. Dr. Mohan garu. Friends, sir, session is today afternoon at 2:45 p.m. He is going to highlight on industrial ecology, circular bioeconomy, transformative solutions for sustainable development. Now, it's time, awaiting time for signing up MOU with the National Remote Sensing Center, ISRO, Hyderabad. Before that, I request one of our coordinator, Dr. B. Lila Mari, HOD of TCE, to introduce the chief guest of today's function to the audience.
A very good morning to one and all. It's my privilege to introduce today's chief guest, Dr. Prakash Chauhan Garu, on the occasion of Technology Conclave, Swarnandhra and Vikasit Bharat 2047. Dr. Prakash Chauhan Garu is a renowned scientist of ISRO and an expert in remote sensing and planetary science. He obtained his MTech in Applied Geophysics from IIT Roorkee and PhD in Physics from Gujarat University. He served as a director of the Indian Institute of Remote Sensing IARS Dehradun and is currently associated with the NRSC Hyderabad. Dr. Chauhan Garu made significant contributions to Chandrayaan missions, particularly in the detection of water molecules on the moon using hyperspectral imaging data from Chandrayaan-2. He also contributed extensively to Earth observation, ocean and atmospheric studies, disaster management, and planetary remote sensing. Dr. Chauhan Garu has received several prestigious awards, including the Asian Pacific Region Excellence in Space Award 2023, and has published over 150 research papers. He is a fellow of leading scientific academias and a corresponding member of the International Academy of Astronautics, IAA. So welcome, sir. And I thank the directors for giving me this opportunity. Thank you.
Now, I request the Honorable Vice Chancellor, sir, for signing up MOU. Sir, that will be great. Satyanarayana, please come on to the dais. Now I request Sri Satyanarayana, please brief about the activities going to benefit the JNTU Kakinada.
Thanks for the opportunities. Good morning to all of you, ladies and gentlemen. Respected Director NRSC, today's Chief Guest, respected Vice Chancellor, JNTU Kakinada. This MOU is formulated when Dr. Prasad Garu visited Andhra University last year, Teachers Day. We had a signing MOU with Andhra University. Then Prasad Garu also initiated that. Why can't we have a MOU with NRSC, JNTU also? Basically, this MOU, students exchange program, faculty, and for PhD purpose, and using the spatial data.
for the purpose of the research and the faculty as well as the analysis scientists for the PhD bit. So this is a non-financial MOU, umbrella MOU we call it. So both the way it will be beneficial to the JNTU, Kakinada as well as NRSC. I wish that this should get success. Thank you.
What is that? What is that? That arm. Please, sir. Thank you.
At the time, the NRSC for kindly accepting our request to sign the MOU for the academic and research collaboration. The idea is, we would like to sign MOU with all the research so that the academic quality of teaching will go up, so that there will be interaction for our students with the scientists. Similarly, we would like to send the scholars at least for 1 month time to stay in these research laboratories, learn what the best practices going on in that laboratories. So this is the beginning of signing an MOU with the research laboratories. That's the reason why it's historic day for us, also opportunity for us. We also would like to sign an MOU with the other research labs also. We'll correspond with you, sir, because time is short now. So that I say, request all the scholars to make use of this. You know that NRS is the leading institution of the spatial technology. Those who are doing the research in those areas, maybe the land cover or the photogrammetry or the GS related spatial applications, etc. You can always visit the NRS. It's not far up, just in Hyderabad, and you can see what they have the best equipment, the best tools available. So that you can play with something. Most of the software is also applied to become made free of cost to the users. For any citizen also they can download the software and they can identify the location of their property or the facilities, etc. So I request the scholars to make use of this wonderful opportunity. Thank you once again. Thank you.
I request direct analysis to be movement to the vice chancellor, the custom practice analysis. Ramana garu to join formal analysis.
Please.
This is the rocket which will carry Indian astronauts into the space.
Thank you.
Yes.
This rocket carries the Gaganyaan Yatri. Recently that Shuklaji has come no, from the space. This rocket won't carry. Thank you. Now, I request our chief guest, Dr. Prakash Chapandi, to address the gathering. Good morning, namaskar to everyone. Respected Professor C.S. R.K. Prasad Garu, Honorable Vice Chancellor of JNTU Kakinada, Dr. C.H. Mohan Rao, one of our veteran of science and technology and former PhD director, and I don't know how many hats he's wearing, but today's function, he is the torchbearer for this entire program. Dr. B. We also have with us our AV director, Dr. Mohanji, as well as Narasimha of the of course, Madam, she talked about, in such a wonderful manner, she narrated the story of, how the milk processing happened and how it became the household stuff in the entire country. In fact, I wanted to say the Annapurna, the name itself is very hard. Round of applause to everybody for doing that wonderful work. And of course, Mr. Ahmed Khan sir, then I will believe Ramanaji and other dignitaries of the dais. Dr. Khalid Sen, our old friend and mentor and colleague from NGRI. Other seniors, present in this hall. All dear students, research fellows, faculty members of JNTU, my greetings to each one of you on this occasion when we are celebrating the technology day here at the beautiful campus of Kakinada. I would like to thank the Vice Chancellor sir, as well as ASTC, our Mohan Rao sir, as well as our Narasimha Rao sir. And of course, AP Space Academy is also partner in this institution. So, our own Ramnagar for inviting me to this wonderful place of the country, the Godavari Delta, and the beautiful city of Kakinada. In fact, I have never come to this area, so it was my desire to visit this beautiful place and also to get acquainted about the local, cuisines as well as about the local surroundings and to know more about this particular area. So thank you very much, sir, for your invitation. And this program, as already the stage has been set, National Technology Day's importance has been told to you. And in context of many of these discussions, what I would like to do in next 50 minutes, I'm not going to go with a PPT based presentation. I thought I will only have a small simple dialogue on the use of technology and in the development of our own country, and in particular, I come from space sector. I would like to talk about how the space technology is playing a very important role in terms of changing the lives in this country and beyond our borders, and also, what kind of work we are doing in terms of space exploration, knowing more about the objects in our neighborhood, like our own moon, Mars, as well as we are now planning missions to Venus. We also have launched a mission to study Sun, and to look for, do we have some kind of signatures of life beyond Earth? That's the major question, which is basically driving this exploration. But there are certain other strategic aspects also in terms of developing various technologies for space exploration. So that's what I'm going to do on this, occasion when we are celebrating Technology Day here in JNTU Kakinada. So, as far as the Technology Day is concerned, it's not merely a celebration. It is a reminder that India's scientific confidence, technological self-reliance, and the extraordinary capability of our scientists, engineers, and innovators and young minds. The day also commemorates the historic technological achievements of India, as has been described earlier, and also celebrates the spirit of innovation that continues to drive our nation forward. We had large advances in various fields of science and technology, and many of the eminent experts are sitting on the dais, and off the dais, they are going to talk to you about those respective areas. And one important, aspect of attending this type of conferences, seminar, and where it's of my personal interest, I do come and love to come to such places. That you see, even on the dais itself, there are 10 or 12 people with almost more than 30 or 40 years of experience in their respective areas. So combined together, you have more than thousands years of work sitting with you and listening something with them, getting even few sentences of wisdom, enriches your own knowledge. A few of my friends used to have one mentor, he once told, see, you will be always, most of us will always have friendship with people in your own domain.
space scientists will have a lot of friends, those who are in space field, biologists will have friends, more biologists, atomic energy, because of your peers. But there is, you know, you don't gain much from them by sitting with them, because most of the things are being discussed over a period of time with long association, and you know many of those things already. So it is always good to have friendship, with people from diverse backgrounds, so that you can know more and you can get enriched in different areas. And these kind of conferences where so many eminent experts come, especially for young people, this you must take advantage of the presence of such kind of wonderful people in this type of conferences, so that you can gain, if not a deeper insight, but at least you will come to know that what is happening in this world at a national as well as an international level. Otherwise, such opportunities you will never get. So in that context, this particular conference or this type of meetings and functions becomes very important. Now, as far as so I'm not going to talk about what is happening in the field of biotechnology, supercomputer, quantum computing. These are some of the advanced areas: artificial intelligence, machine learning. Madam talked about agri-tech, food processing. These are some of the bigger challenges for our country as we are aspiring to become, the Vikasit Bharat. So to solve some of those problems, we have to find out technological solutions. One of the major problems which are going to solve is in terms of sustainability. Sustainability of the resources, especially if you talk about groundwater resources. I'm sure Professor Kalatan will talk something, even though he's going to talk on gas hydrates. But these are all the subjects. Many of the states in India, they are basically becoming, what we call as the dark states. The depletion of groundwater is a big problem. So the future generations will not have those resources if we don't think of talking about sustainability. Energy sustainability is one of the major challenges. Environmental, cleanliness and pollution eradication in big cities and large part of our urban setup is a big issue for this. Plastics, contamination, even in coastal areas. If you see the fisheries around you, large amount of analysis studies have shown that there is a good amount of plastic content in the guts of fisheries. Does this have any relation with the cancer? We have cancer experts sitting over here in the dais. So many of these challenges we need to address by the adaptation of science and technology in times to come. But when it comes to the space domain, space is known as the last frontier over a long period of time, because space is difficult, it's complex, and it is unforgiving. You have to be 100% perfect to reach to the space and to do what you are supposed to do. Even 0.1% of mistake will cost you the mission. And some of us recently have tested that when one of our most popular or most successful rocket, the PSLV, which has done 60 successful flights, failed in last 2 consecutive flights. It's a nightmare for many of us that what really has gone wrong, that to not once but twice with such a kind of a operational system. So the space basically becomes what is known as the last frontier of technology. And it's an amalgamation of multidisciplinary fields. We have in ISRO, we have around 17,000 regular scientists, engineers, and technologists with us. And we have a breed of what we call A to Z. From the agriculturist to a zooplankton experts, and of course all core engineering people, they're all there in ISRO. Some of you may be wondering what an agriculturist is doing in ISRO, but that's the beauty. I will talk about it subsequently. What a biologist is doing in ISRO. But we do have a large amount of people in our setup, basically to translate that knowledge from space into specific domains. You also need domain experts. Ramna is sitting here. He has served more than 35 years. He is a PhD from IRI, agriculturist, sitting in ISRO. So you can talk to them, some of you, later on when he is available to you. So I think in the morning, we also heard, the difficulties about the, getting food in this country in 60s. But that was also a time when one of the visionary leaders of India, he was thinking of investing heavily in the world of space technology. when a country which is suffering and not have even, enough food to give it to its people, it must be a really courageous man to dream and to invest heavily, because space is also a sector where you need to invest a lot of money. But Professor Vikram Sarabhai, he had a vision at that time that India must, invest in the space technology and of course atomic energy at that time. While we were developing, and many people mocked and also must have, discouraged to do so. But, with his persistent vision and with the support of government at that time, India started its space program in 1963 with with a small gift from United States of America. And that gift was a Nike Apache sounding rocket, a small rocket, which was supposed to be launched from Tumba, which was a fisherman village. And the fishermen of that area were trying to gift one church to start a space program for the country. And that 1963 small gift, after so many years, last year, we have done what we call as the return gift to USA by launching one of the most expensive Earth observation satellite ever built in the history of space exploration. It is called NASA Electrosynthetic Aperture Radar Mission. It's a radar mission which was jointly developed by ISRO and NASA with JPL, Jet Propulsion Laboratory in Pasadena, California, making L-band synthetic aperture radar. Synthetic aperture radars are basically a kind of an imaging system which can see Earth 24/7, whether sun is there or not there, whether clouds are there or not there. It is like a torch, which we use without having, the passive source of illumination like sun's light. So this radar is a unique radar which was developed by them, L-band, and there is another frequency which is called S-band, which is a much smaller wavelength compared to the L-band, which was developed by us. So out of 10,000 crores, of the total mission cost, 1,000 crore is only spent by India. 9,000 crore investment is coming by US. The entire payload, or what you can say the sensor, was brought from JPL and then it got integrated in ISRO's URL satellite center. Then it got, transported to our Sriharikota launch pad, which is not far from here. And then it was lifted off by one of our mighty rockets, LVM-3, very similar to the rocket which I have just presented to our Vice Chancellor. So you can imagine that a country which started that program with that small sounding rocket which goes few kilometers and makes measurement of temperature and humidity while it is traveling. The same country, after 70 years of hard work, dedication, and so-called Atmanirbharta, has reversed this entire game. And today, all these developed countries are lining up in terms of doing collaboration with us. So I think this is a real story of the space program, and with that dedicated efforts of not only space scientists, but many scientists in this country who has toiled hard and without much remunerations. Many people during those eras have gone to the greener pastures. They decided to work in developed countries. But you must appreciate and acknowledge the efforts of the people, those who remain in this country in spite of having qualifications to go and earn huge amount of money, simply because of the passion and dedication and their commitment to see this country. We started with Vande Mataram. We must pray first to our land. That is what is the effort. So I think on this National Technology Day, it will be a real tribute to pay at least a round of applause for all these wonderful efforts. To remember that we must make our country a developed country, because before the British came to this continent, India used to contribute almost 25% to the global GDP. And when they left us in 1947,
our contribution was only 1% to the global GDP. This kind of depletion of resources and exploitation and pathetic situation we were left with, and doing a turning around in last 60, 70 or 75 years or 80 years is a real miraculous story with the kind of complexity we have in this country. So the visionary effort of Professor Sarabhai, which has led to the foundation of space program in India. We started having activities with the vision of Professor Satish Dhawan, who became the chairman of space after the early demise of Professor Sarabhai at the age of 52, and he steered and made the foundation stone of all our space program activities, including conceptualization of PSLV, GSLV, rocket programs, as well as the satellite programs, space application programs, and space exploration programs. So that was the vision of Satish Dhawan, which has given the foundation stone for many of the success stories of ISRO. So today, ISRO, we have demonstrated the world-class capability of satellite development, launch vehicles, planetary exploration, navigation systems, communication satellites, and Earth observation technologies. When we have to develop a rocket by its own, normally any complex thing, you will say that it's not a rocket science. Something. So that means rocket science has to be really a difficult thing to achieve. And that's why the appreciation for the rocket, even today the rockets keeps on failing. Not only our rockets, the American, Chinese, Japanese rockets are failing. It's a difficult ball game altogether, because what is a rocket? Rocket is a time machine. You have to develop enough thrust. You have to have an engine which can produce sufficient enough thrust to leave the gravitational influence of Earth and give the vehicle a sufficient amount of velocity so that it can lift off and it can take some mass, typically thousands of kilograms of mass, into Earth's orbit or any other orbit. There are 3-5 kind of orbits depending on your destination. You have to design your rocket, and your engines has to be strong enough to get that type of thrust. And to give that thrust, you have to burn good amount of fuel. So there are different type of fuels. There are solid fuels, there are liquid fuels, there are fuels basically which are difficult to handle. There are fuels which are easy to handle, but some of them, they cannot be handled at the normal ambient room temperature. They need to be cooled sufficiently, like hydrogen, because the volume is very high. So if you have to have tanks which are basically manageable, it has to come down, it has to be solidified or liquefied. So there are technologies, especially the cryogenic technology, which was denied to us. The cryogenic engines gives you enough leverage compared to solid engines, etc., to produce that enough amount of thrust to take a heavy satellite into the space. This technology basically was available with Russians. They were also willing to share this technology with us in early 70s or mid 70s, early 80s. However, because of the international geopolitics, I don't want to take name here of those countries, consistently, the efforts were made that we must not get the technology. Like there are efforts happening in some country today not to have the nuclear stuff. But this was taken up as a challenge in some of the laboratories, and we demonstrated and developed this highly complex cryogenic rocket technology. On this technology day, we must appreciate and thank all those people, those who worked dedicatedly, tirelessly in terms of developing this cryogenic engine in this country. That today all our powerful rockets, especially our GSLV rocket, and of course the rocket which is going to be used for the human space program, are essentially working on this cryogenic technology. And now we are also going to work on semi-cryogenic technology, which is basically going to propel the new generation rockets of India. So that's another wonderful thing which has been developed in the country as far as the niche technology or highly complex technologies are concerned. Of course, when it comes to the scientific achievements of many of these missions which has been launched, especially in context of the planetary missions, many of you must have being recalled or remembering, the wonderful events which have happened. And many of us been live when Chandrayaan-3, landed on the southern, polar region of the moon surface. And India became the only country to land successfully and soft land successfully on the most southern part of the moon surface in the month of, August, 23rd August, and that was the year of 2023. So that basically has changed the S&T profile of the country in the global perspective for all together thing. Because it's not a small thing. Lifting a rocket with almost a 4,000 kg class satellite, which has 3-4 different components. It has a lander, it has the rover, it also has a unit called orbiter. So all these things are clubbed together. And when you leave the Earth's gravity, and then when you inject or you come into the gravitational influence of the moon, that event is called the lunar injection event. That itself is a very critical event. You have to precisely calculate, you have to have a capability of mathematical modeling of the trajectories and to know the kind of forces which you expect when you reach to this orbit. And if you don't calculate precisely and you don't reduce your velocity enough, what is going to happen? You are going to either crash into the moon or you are going to leave the moon's gravitational influence and you will be lost into the deeper space. So that is the capability of doing precise mathematical modeling of orbital trajectories, knowing how much amount of velocity reduction has to be done. Anything, a satellite in space moves with a velocity of around 9 kilometers per second. 9 kilometers per second is around 20,000 kilometers per hour speed. So with that speed, you have to slow it down. It is something like that. You are going in a straight road, and when you come closer to any body, you have to take a curve. So like imagine when you are driving a motorcycle or a cycle with a speed of around 30 kilometers per hour or so, and you have to take a turn. You cannot take a turn with that. Maneuvers has to be done. You have to fire retro rockets or the rocket. There are small, minute engines are there on a satellite body which carries the fuel. You have to reverse direct. If you are traveling in this direction, in the reverse direction, you have to fire the thrust and then you have to reduce the speed. And all these decisions has to be done, on board. The thing can be done from Earth because you are almost 384,000 kilometers away from the Earth's surface. That's the distance, average distance of moon from Earth. So that requires software development, that requires telemetry, telecommand, commanding your satellite sitting here from Earth. You require precise engineering capability in radio communication. All that things happens in space technology. That is why it is a highly multidisciplinary field. And that once you are in the orbit of the moon, then you have to descend. You must know the accurate gravitational profile of the moon surface where you are going to land. Otherwise, if the trajectory is not perfect, reduction of your velocity is not correct, again you are going to crash. As we crashed in Chandrayaan-2, after coming very close to the moon surface, we were only 200 meters away from the moon surface, then we crash landed onto the moon surface in 2019. And many of you must have seen those scenes also. Our Prime Minister was also there. Of course, success could not come at that time. But that also taught one lesson that we need not worry about our failures. Failures are going to happen in life. That is a lesson for all these researchers. Don't worry about your failures. Failures do happen. They may continue to happen. But what is most important, how quickly we can learn from our failures. We did a lot of data analytics after that. We identified the problem areas, and then all those problem areas were addressed while Chandrayaan-3 experience happened, and that gave us quick success while everything was addressed. So it is important to learn from your failures, do corrections, but if you continue to fail and don't learn, then failure is not good. So that is one big lesson in science and technology, which basically some of you must always keep in mind that even if the temporarily or experiments are not giving the desired results the way you wanted, continue to strive hard and do whatever you want to do. Success is likely to come. So these space exploration missions, like for Moon, Mars, Mars also we created history when India became the first country to, successfully enter into the Martian orbit in the first attempt itself. That's a very difficult thing to do because Mars is very far away from Earth. It is around 225 billion kilometers from the Earth's surface. Communication becomes very difficult, and for that we have to have technologies on the ground. We have established what is known as the Deep Station Network or DSN antenna system in Bangalore, Belali, which is a 32-meter antenna dish, and that's precisely, talk with a satellite which is 225 million kilometers away using radio frequency signals. And the signal also takes 20 minutes to reach it because of the distance is so high, because all electromagnetic radiation travels with the speed of light in space. So these are the stories of of exploration missions. You can always ask question why you are worried about so much about moon and why all countries are worried about moon. Nowadays you must have seen, recently Americans are planning to put moon again, to man onto the moon again, the Artemis program. Artemis 2 is, just recently concluded. They took 4 astronauts. They went around the moon surface and came back and splashed into the Atlantic Ocean. Recently, many of you must have followed that story. So what is this rush to moon? Why everybody wants to go to the moon? And the answer is very simple. The answer is the way we have been exploiting our own Earth. The global population is likely to cross around, I think, 800 crore or so people. They are already 700, 650, 700 crore or so. And the way the Western economies work, the consumption rates are much, much higher than what we have. The fight for resources is already happening, as you can see globally. So it is estimated that after 50 or 100 years, the way we are growing and the consumption is increasing and natural resources comes, all kind of things which you do comes only from this planet. So this planet will not be sufficient for us. We will require, there are critical studies people have done, we will require 1.5 Earth, not 1 Earth. From where this 1.5 Earth will come, the 50% Earth or the materials, the resources has to come from somewhere. And the easiest place, at least some of the resources can come, and people have already started eyeing, is the moon, which is only, as I told, 384,000 kilometers away. With a good powerful rocket, you can reach moon in 3 days and then come back with some trucks of loads of lunar rocks, which has lot of minerals, lot of mafic minerals are there. It also stores a good amount of helium, which is basically getting trapped onto the sun surface, on the moon surface, coming from the solar wind, because there is no atmosphere on the moon. And then if we can perfect the nuclear technology of harnessing helium in terms of, the fusion technologies, then it can become a potential source of continuous energy for all of us. So all these ideas, which may fructify, some of you, especially youngsters in your lifetime, also can see some of this getting reality, because many things which were conceived in Star Trek in 50s and 60s, all this your mobile phones and all, somebody imagined those days that it will happen today, it is happening. So this is how the technologies evolve. But apart from this space exploration stories, the real strength of India's space program lies for its societal contribution. Today, space technology supports agriculture through crop monitoring, precision farming. It assists fishermen through ocean state forecasting, potential fishing zone advisories. It strengthens disaster management through flood, cyclone, drought, forest fire, and landslide monitoring. It enables urban planning, water resource management, environmental modeling, infrastructure development support, and climate resilience. And satellite communication has connected remote villages, telemedicine and teleeducation services have extended outreach to many rural regions, especially our island territories, Andaman, Nicobar and Lakshadweep, and rural areas in Himalayan region. Navigation systems like Navic and of course the GPS system are strengthening the positioning and timing services of transportation, maritime operations, strategic sector.
geospatial technologies are empowering governance through digital mapping, smart cities, and land record modernization and rural development initiatives. If you are ordering a pizza today at your home, if you are getting something from that, Blinkit or somewhere, 10 minutes, food item coming to your home, many of you may not realize that you are using space technology. Even if pizza cannot come, if this so-called GNSS satellites are switched off, because your live location will not be, available. That boy who's bringing, he cannot reach to your home because nowadays, people earlier in our days, people used to ask किधर जाना है, उधर जाना है, सब रोड पे कोई बताने वाला था. आज कोई नहीं बताता क्योंकि किसी को नहीं पता है. Everybody is doing it through your mobile phone only. So this your live position, it's called PNT service, position, navigation and training service. It comes from a set of constellation of satellites. Typically, we are all using in India, as many places in the world, an American system called GPS, Global Positioning System, which is basically done by the Department of Defense of government of US federal government. But there are other constellations like Glasnost of Russians, Baidu of Chinese, and of course India has developed its own regional constellation of satellites. It's called NAVIX series of satellites. We have 8 such satellites. So now many of the mobile phones which are getting manufactured in India are having these chips which are also NAVI connected. So this is one example. Another example is if you go to your villages and rural villages, you want to withdraw your money. The entire communication from that ATM to your servers, which are there in big cities, bank servers, is happening through a VSAT antenna, which is sitting on the top of that ATM room. And that communicates to a satellite at around 36,000 kilometers away called geostationary orbit. And then this entire transactions get completed because there is a high throughput internet connectivity and communication connectivity is provided by this satellite communication. So remember that also you use, and then many other things like all your DTH antennas which you are putting and getting your entertainment and all kind of things, etc. at your home. They're all coming through that. And of course, wherever a live telecast from a cricket match or something is there, the OB vans are put outside the stadium. Many of you have gone and seen a cricket match. You must be seeing some trucks mounted with antenna systems are there. They're all communicating to satellite communication. Then of course, it also does the Earth observation technology or remote sensing technology, imaging the Earth today. Imaging the Earth today, we have capability in India to see 25 centimeter object from space. I don't have slides, otherwise I could have seen you a video where an aircraft is taking off and we can monitor it from space 500 kilometers away. So that's the kind of technology we have today in this country. India is a country which is growing with 7 to 8% of GDP. In your own Kakinada city itself, within 6 months, new buildings comes up, new flats comes up. If that flat is not mapped onto the digital map which this Swiggy fellow or that pizza fellow is using, the item cannot reach to your house because house is not there on the digital map. And the way Survey of India creates maps, it takes 25 years to make those maps updated. So all the maps are getting instantly updated today because of this Earth observation capability at high resolution level. Yesterday, I think yesterday or day before yesterday, we celebrated the first anniversary of Operation Sindoor. And some of you, if you have seen the headlines, it also talks what is the contribution of space in Operation Sindoor. And we ourselves at NRSC have done significant amount of work to support our tri services because today's war is not fought by man to man. Infantry wars are not big today. You are seeing what is happening with Iran and Israel. 2,000 kilometers away, Israel and Iran are fighting with each other only through aerial routes. And when you have to fire an aerial system, a missile system, you must aim for an object. You cannot fire randomly because, of course, there are rules of the war also. You have to select your military targets. Now, target selection is the most important aspect. If I have to hit on a terrorist camp precisely without having,
ancillary damages, I must know the accurate location of those places. Now, how do you know? Sitting 500 kilometers away with no access to that country, even though there may be some ground intelligence, but you have to have precise information about it. So this is all being done today with the help of space technology, with the help of imaging technology. We create images, we rectify them, we correct it for the topographic variations, it's called ortho rectification process, and very precise location of each object in terms of the latitude, longitude, height from the mean sea level are all traced and mapped to very high precision. And then this intelligence goes in many of these operations which you see today. That is why recently you all must have seen that American commercial companies, satellite companies have denied access of satellite imagery over Iran in a near real time basis. Because people will know that what kind of damages are happening. In war, there is something called the fog of the war. You never know who is speaking truth, who is speaking lies. That's the fog of the war. So only way to know that what is the reality is nowadays space. If I say I have hit this place, I must see some signature of that. Next day, if I do imaging on that, I will come to know that what I have hit or not. But as a party involved in war, I will never like to get that reveal that I have been hit because it's counterproductive to me. So best way is to deny access. Now, when you live in this denial era, what is required? You have to have sovereign system or your own individual capabilities to conduct all these things by yourself. And that is what precisely happened in Kargil war when they denied GPS access to us for military operations. And then this Navik operation for the Navik constellation was conceived at the time when Atal Bihari Vajpayee Sahab was the Prime Minister. So, space is not only today a player which is linked with the economic activity. Space is also a very strategic sector. Without that, the security, safety of your boundaries is not possible. And of course, a country which like India, which has 11,000 kilometer coastline, the maritime boundary security is also becoming very, very important. We have to make sure that what is happening in our maritime domain, because many of these attacks like Bombay attack, etc., that is also becoming, the coastal areas are also becoming very, very vulnerable when it comes to the security and safety. So country cannot become a developed country until unless our borders are secure. And in that context, the technology, both space technology, military technology, defense technology, plays a very important role. On this technology day, we must remember, and we have seen it today. See, there is no point in having development and not able to protect the country. Look what is happening in Dubai. What has happened to UAE? They are not having an air defense system or having also but not able to defend 100%. The entire economic growth has gone in vain in 1 month period today. Iran, virtually it is in shambles today. So we must remember as young researchers or as young citizens of this country that protection of the country and its sovereignty and safety security from the neighborhood, the kind of geopolitical environment we live is utmost importance, even though we continue to do our own development, but that development has to be protected against these threats. In that context, the space is playing a very important role today. And one more important program which ISRO has started is also to go into and venture into the manned human space program. We have all spheres with us which we have demonstrated and we have successfully operationalized, but we have not consciously taken the decision to send and to have the persistence human presence in space or astronaut kind of a launch. But now with this Gaganyaan program, which has been approved by Government of India, we have 4 astronauts. They were all designated by Honorable Prime Minister a few years back. They are all military test pilots. In first phase, now ISRO is also opening opportunity for the civilians to become astronauts of future. We have 3 unmanned missions which have been planned. They are called G1, G2, and G3 program.
which are going to be the test flights of entire hardware. G1 is going to be a first, unmanned mission where a robot, a Vyoma Mitra, a kind of a lady robot will be put, and then all functionalities of the modules which are going to space will be tested. Then G2 will have the entire environmental control systems, because if a astronaut has to survive in space, we have to create in the astronaut module all kind of the environmental support system, including the air pressure, and then of course sanitization environment, so that they can survive for 3-4 days. And these two things will be tested in G2, G3 mission. And then finally the H1 mission, that is the human mission, will happen. Once the success of these 3 missions, the advanced work is happening in all these mounts. Recently, you must have seen in press, we have successfully conducted a test where you must have seen that the crew module was lifted by a helicopter to 4 kilometers, and then it was released, and we have successfully tested what is known as the drop test, the deployment of the parachutes. So there you have to have a space grade parachutes, multiple parachutes comes, they open up, the descent trajectory is designed so that the astronauts don't go through more than required thrust, and when they splashes onto the sea surface, they should be able to sustain that kind of gravitational effect on the body. So all the simulations and tests are currently going on, and we have also created what is known as the astronaut training facility for training the future astronauts of this country under the microgravity environment here itself on the Earth. So that is another new dimension of India's space program, which is growing up. It will have a lot of benefits subsequently in the field of medicine, because there are large amount of medicines which can be, or molecules which can be developed in the microgravity conditions of space. People are also talking of growing agriculture in microgravity conditions. Some kind of, refined genetic seeds can be developed only in the microgravity conditions where, you are not, and it's vacuum. There are no contaminations of the microorganisms there in that environment. So it will lead to all kind of interesting research fields and extension of different kinds of science and technology in different fields at space. So in that context now, Government of India has also approved what is known as the Bharatiya Antariksh Station. It will be very similar to the space station, International Space Station. It is run by multiple countries, so mainly by Japan, Russia, and American and European collaboration. And of course, China has their own international space station. So India is going to have a permanent presence in space in low Earth orbit, and we are going to have continuous, access to space in times to come. But for that, we have to, basically work on various technology. Recently, we have demonstrated a docking technology. The SpaceX mission you all must have heard. Where basically we have docked 2 satellites which are moving with a velocity of, as I told you, 22,000 kilometers per hour. These 2 objects are moving, and then you have to bring them together. Their relative velocity has to be reduced. They have to come together and then do docking. Imagine, you have 2 cars moving with huge speed. You have to join them together, and road itself is a tough task, and they have to continue to move with the same speed. So this docking experiment has been successfully done. This will be required even for our Antariksh station, where you must have seen that once the new crew goes, it gets topped up and then it returns also. So docking experiment in space is the most critical technology which is getting developed by ISRO, and it has been successfully demonstrated. It will be also very useful for our Chandrayaan-4 mission, when we are going to bring back lunar samples from the moon surface, because a lot of docking, undocking, and pre-entry technologies will be tested. And of course, we are also have been given a task by our government to land Indian men or women onto the moon surface by 2040. So this is a big vision which will basically enable large amount of technological development in the country. So it's not a small feat. It's a huge challenge, and multiple organizations have to work together to fulfill that particular dream. In this context, before I end, I also must tell you that in 2023, Government of India has also brought reforms in the space sector. It's called India Space Policy 2023. And they have opened the space sector for private sector participation. So this has led to capitalistic, as Ramana was telling, enhancement in the space activity in the country today. So today, a private company can build rockets, they can build satellites, they can make ground stations, they can run, these services for agriculture, water, all kind of sustainable development and governance related services, defense services. And now one of the private companies, startup, more than 250 plus startups in this country are basically today running in the field of space technology. Put together, we have got more than 60 million, 50,000 crore rupees investment only in private sector has come in space in last 5 years or so. Mostly it is coming through venture capital group actually to the country. And more than 5,000 young youth employees are employed in space sector beyond ISRO today. That's the kind of activity which is happening beyond the labs of Department of Space. So this is another revolution which is going on. You all must have heard that last week one of the private company, a new startup called Galaxy Eye, has launched very innovative, first of its kind of satellites. It's called OptoSat, which has an optical imaging system, but at the same platform, a synthetic aperture radar imaging system. So optical imaging system has a problem that when clouds are there, you cannot see, and night you cannot see, but the SAR can supplement that. So this is a very unique thing which has happened, and first time it has happened in the world, which is done by an Indian startup company. So this way, even our Honorable Prime Minister has tweeted, and multiple people, including Vice President, multiple people have tweeted about this great achievement of a young startup company in India. So a lot of innovation in space is happening, which is being done by young boys and girls of India, coming out of the ecosystems of universities in India. Still, the top-notch universities, so-called, I don't want to take the name of them, but they are still not in space. Less than 2% of IITians work in ISRO. So you imagine, if we are able to retain somehow this talent in each country, what kind of wonders we can do when best of the best people are not working for this, and we could achieve this. So this is another point of wondering. We all must think as a country that how to, keep the best talent in this country. What is to be done as a policy maker? I think some incentivization and some policy interventions are required with this front, so that we must make sure that whatever best trained and talented people we are bringing out of our education system, they must contribute to the national economy or national development. We have created in this process for private sector a entity called InSpace, which is a regulatory body, which basically is supposed to regulate and promote the space sector in this country through private sector route. First private, orbital launch is likely to happen either this month and or early in the first week of June by another startup here in Hyderabad only. It's called Skyroot, and they have got a 60,000 SFT facility in Aero City, very close to the airport. And they are aspiring to become the first rocket company from India, which will basically cater to the global launch markets, and they will give good and tough competition to SpaceX, the Elon Musk company. So that's the kind of vision with which these boys and girls are working, and let us salute to them. That they are developing all kind of cutting edge technology in private sector with their own investments. Some of them are bootstrap companies also. They are basically from the promoters, funding itself there. So with that, actually, I would like to stop, and we would like to remind that, friends, technologies, they are basically changing generations altogether in terms of now, use of artificial intelligence, robotics, drones, and cloud computing. These are becoming household things, and we are also thinking to shift now entire AI-based data center infrastructure to space. Many of you must have heard recently China has launched a data center in space, and 2 days back Pixel, another private company, they have decided their plan to shift the entire computing infrastructure for AI systems in space. Why? Because for any artificial intelligence data center, you require large amount of electricity, you require cooling efforts, this produces a huge amount of heat. Any AI, if you are using ChatGPT and all, Trump always says that why I have to spend money for Indians to use AI infrastructure sitting in US because I am burning my water, I am burning my electricity and running this data center, and these fellows are using advantage of that. So huge amount of resources are required to run these data center incomes to keep them cool and as per electricity. So if you move the space, electricity is free because you have sunlight, you have solar powers, and space is very cold place. It's minus 50 degree or minus say 100 degree or so. So you can radiate heat outside. So with that new innovative concept, now people are thinking to transfer entire data center architecture into space. So you will have satellites in future, which will do computing in space and through communication links, either optical link or RF link. All that information will come down to you, but computing will happen in space. So that's the kind of innovation which our people are planning as far as space is concerned. So I would urge all of you that you must develop scientific temper and curiosity, focus on solving societal problems, promote innovation and entrepreneurship, work on technologies related to climate resilience, sustainability, healthcare, agriculture, and digital innovations, build indigenous technologies that strengthen national self-reliance and collaborate across disciplines and institutions. And I'm very thankful today that in that spirit, JNT to Kakinada and NRC has come together to sign this MOU, and I think it will become a torchbearer, and hopefully, as the Honorable Vice Chancellor has told, we will be able to have more MOUs with other RBD organizations. So I congratulate JNT Kakinada on this occasion. So with these words, friends, on this technology day, let us ensure that technology becomes a force for peace, development, environmental sustainability, and human welfare. I once again thanks the JNT Kakinada for giving me this opportunity to share my thoughts with this distinguished gathering over here. I wish this particular conclave a grand success and the university research scholars and the students a greater success in all their future endeavors. Thank you very much. Jai Hind, Jai Bharat.
Thank you very much, sir. With your lecture already became grand success. One point I want to mention with you. After CSRK Prasad Garu became the Vice Chancellor, he changed his office, VC office, by putting the portraits of Homi Baba and all. I request you to have a look at that. Yeah, thank you, friends. I think it's time to felicitate our chief guest, Sri Prakash Chauhan. We sincerely request you to, sir, accept our small token of respect to felicitate you. Please come forward. And one more point I want to request with you, friends. I think it's time we can give standing ovation to our chief guest for his lecture. Lecture. Excellent, memorable lecture. Thank you. Lecture, please come forward. Yes. Now, I request Honorable Vice Chancellor, sir, to felicitate Dr. C.H. Mohan Rao, Chairman, Scientific Advisory Council. I request Rector P. Subbarao to please join.
Sir. Thank you. Thank you.
Now, I request the Dr. Prahlad Ragan, please accept our felicitation. Please come forward. All of you, please relax.
Now I request Dr. Azmat Kamalji, ANRS Prime Minister State and former outstanding scientist of IACT, please accept the constitution. Now I request Madam Sridevi Annapurna Singh, former director CSR CFTR. Now I request Dr. S. Venkat Mohan Garu, Director CSIR Neeri, Nagpur, please come forward. Now, I request Professor Kalachan say.
Subject, sir.
Sir, he is JC Board National Fellow at CSIR and CSIR NDRA Hyderabad, former Director Vadia Institute of Himalayan Geology, DSP Dehradun. He is going to deliver lecture on gas hydrates, a potential clean energy resource for India today afternoon. Now I request Dr. B. Harinarayan Garu, please come on to the dais, accept our token of respect. He is going to deliver a lecture on towards energy security through renewable energy opportunities, challenges and innovation. Now, I request Professor P. Subbarao, Professor of the University, to propose vote of thanks. Yeah, two points, please. Now I request Dr. K. V. Ramana, Secretary, AP Space Tech Academy, to accept this registration.
Lights in the
Secretary, Academic for Science, Technology and Communication. Please accept these registrations, sir. Please come forward.
చేంజ్ చేయగలమా స్లైడర్
Thank you, sir. Now I request Professor P. Subbarao to propose the vote of thanks.
Very good morning to you all. Technology may power the future, but gratitude powers human relationships. President of today's function, Professor C.S. Honorable Honorable Vice Chancellor, Jawaharlal Technology University, Karnataka. Esteemed chief guests of honor, respected dignitaries on distinguished scientists, academicians, researchers, faculty members, students, media representatives, ladies and gentlemen, very good morning to you all. It's my proud privilege and formal vote of thanks of the technology of Swarnandhra and Vikasit Bharat participants. At the outset, I express my profound gratitude to our visionary leadership of Jawaharlal Technological University, Karnataka. My heartfelt gratitude to Professor C.S. Honorable Vice Chancellor, Jawaharlal Technological University, whose visionary leadership continues to steer the university towards innovation, research excellence, and global academic engagement. Our sincere gratitude to esteemed chief guest, Dr. Prakash Chauhan, Director, National Remote Sensing Center, ISRO, Hyderabad, for delivering an enlightening and thought-provoking inaugural address. Sir, your words have ignited our young minds to dream beyond boundaries and innovate for national development. Special note of gratitude to our esteemed guests of honor. Your gracious presence and inspiring hearts, lifelong contributions to science and technology have truly enriched this gathering. I greatly acknowledge the presence of Dr. C.H. Mohanrao, Chairman, Scientific Advisory Council, former Director, CCCM. Sir, your insightful reflections on scientific temper, research culture, and responsibility of the institutes towards innovation have deeply inspired the gathering. Your words reminded us that true science is not really about discovery, but about transforming the society through knowledge and integrity. I extend my sincere thanks to Dr. Raghunath Rao for his presence, the founder, Director, Homi Baba Center, Cancer Hospital. Sir, your motivating message on healthcare technology, service to humanity, the role of science in serving the society, touched every heart present here. Your journey itself stands as a living example for dedication, compassion, and visionary leadership. I also acknowledge Dr. Ahmed Kamar, ANRF, Prime Minister Child, and the founder of Outstanding Sciences, IICT. Sir, your thought-provoking address on advanced science, research, innovation ecosystem, and India's scientific future has energized our young minds. Your emphasis on interdisciplinary research and global competitiveness has given a new direction to aspiring researchers. I also thank Dr. Sridhar Anupurnasti for her presence, the former director, CFTIR, myself. Madam, your inspiring observations on food technology, sustainability, scientific leadership have enriched this conclave immensely. Your message beautifully highlighted how science can directly improve the quality of life and societal well-being.
I also acknowledge greatly the presence of Dr. S. Venkata Mohan Garu, Director CSIR, NERI, Nagpur. Sir, your powerful message on environmental sustainability, clean technology, responsible innovation has inspired all of us to think beyond the technology towards the sustainable development. Your address has strongly reminded us that the future belongs to technologies that to protect both the humanity and nature. I also extend my sincere thanks to Professor M.H.M. Krishna Prasad, the organizing secretary, for his meticulous planning, dynamic coordination, and tireless efforts in organizing this prestigious technology conclave. I also deeply acknowledge and thank Dr. K.V. Ramanagaru, Secretary, AP Space Tech Academy, and also Sri C.L. Narasimha Garu, Secretary, Academy for Science, Technology and Communication, for their inspiring support and association in making this conclave a platform for scientific interaction and technological enhancement. I also extend my heartfelt thanks to all the delegates, scientists, researchers, faculty members, industry experts, scholars, students, whose enthusiastic participation to learn, interact, innovate has added immense value to this conclave and gives true meaning to this technology conclave. My special thanks to all the organizers, coordinators, faculty members, technical team, volunteers, student coordinators, media personnel, supporting staff, whose dedication, tireless hard work, and teamwork to make this conclave possible. Behind every successful event, there is a silent hard work, and today's grand success reflects that collective effort. Dear students and scholars, may this conclave inspire you to transform curiosity into creativity, ideas into innovation, and knowledge into national building. Before I conclude, let me leave with a thought. A nation that invests in science and technology invests in its future generation. With immense gratitude to one and all, I once again thank every dignitary participant for making this inaugural function a grand, meaningful, and memorable one. Thank you all. Jai Hind, Jai Bharat.
Second, last event of a formal inauguration, national anthem. Afterwards, immediately keynote lecture, Dr. Swarnandhra sir's lecture will start. National anthem, please.
Vande Mataram, Vande
Thank you, sir. All of you please occupy chairs. Now, the session. Keynote lecturer Faculty Nagaraj, founder director Govi Baba Cancer Hospital, Visakhapatnam, on role of technology in healthcare for 40 minutes, please. Now I request the student volunteers to introduce Dr. D. Swarnandhra to the audience.
Good afternoon, everyone. It's my privilege to introduce Dr. D. Swarnandhra, an eminent medical oncologist professor and head of medical oncology at MNZ Institute of Oncology and Regional Cancer Center, Hyderabad. With over 3 decades of distinguished service in cancer care, clinical research, and oncology education in India. He is an elected fellow of CQNZ, the American College of Physicians, the Royal College of Physicians, and Andhra Pradesh Academy of Sciences. He is also the recipient of prestigious Dr. P.C. National Award for Excellence in Oncology. He has played a pioneering role in developing cancer infrastructure in Andhra Pradesh, including establishing first medical oncology department and comprehensive cancer center at the first hospital-based cancer institute in Hyderabad and the first hematopoietic cell transplant unit at NIMS. He was also instrumental in establishing a comprehensive cancer hospital at Visakhapatnam and the Tata Memorial Hospital. A leader in clinical research and innovation, Dr. Swarnandhra became India's first ACRT certified clinical research physician in 2004. Initiated the DM Medical Oncology course at NIMS in 2005 and pioneered phase 1 trials. His national and international collaborations include partnerships with the University of Oxford, CCMG, NIM, and several premier institutions. He has made significant public health contributions as National Coordinator for Cancer Screening and Prevention under NRHM NCD and as founder of Medical Oncologists Forum and Childhood Cancer Study. Academically, he has authored over 284 peer-reviewed publications along with 9 book chapters and 2 monographs. We are truly honored to have such a distinguished expert among us today. Please join me in warmly welcoming Dr. Swarnandhra. Welcome.
Good afternoon, everyone, and thank you for the invitation and the very kind introduction. Will it come here? Anyway, my connection with this engineering college dates back to before it became part of JNTU. It was called College of Engineering, Kakinada. This 110-acre mango grove, it was originally a mango grove, actually housed several bunkers from the World War II time. So you can still see the MES dates on small culverts within the campus. So it is that old. So I'm sure it will soon be celebrating its Diamond Jubilee as well as Platinum Jubilee, finally the centenary celebration. I am also connected in a different way with this auditorium. In that the alumni which sponsored this, the Engineering College of Kakinada Alumni Association, also support a lot of cancer screening and vaccination activities in North Coastal Andhra Pradesh. So the monies which your own alumni contribute in the United States are routed through this alumni association for the cancer screening and vaccination efforts. So I'm very happy if I tell them that I have been in this auditorium, which you have sponsored, they'll be the happiest people in the world. So my job today is to tell you a little bit about technology in healthcare. Medicine, as you know, is mostly dependent upon science and technology. Technology is application of science for the benefit of mankind. And one of the most benefits is technology is
always present when you practice medicine, whether it's a stethoscope or a thermometer or a BP apparatus to a very sophisticated next generation sequencing machine or a phenomenally effective way of treating diseases using biotechnological products like CAR-T cell therapy. It is always technology which is at the background. Whether you take from the simple EMI, most of you heard about EMI as if you know it as his master's voice, that is where MRI was discovered. Okay, so Armstrong discovered MRI when he was working in the EMI laboratories. He was a physicist who discovered the MRI and how to tap the NMR signals to image body without any radiation. So these are all advances in physics, chemistry, or maybe pharmaceutical industry, and many other branches of science and technology which bring succor to those who are suffering. So let us see what are the top 10 technological advances in healthcare for the years 2025 and 2026. So this is something from the American Society of Clinical Oncology, artificial intelligence and machine learning for predictive analytics. So they can do an analysis of any image you want, be it an MRI, be it an EEG, an ECG, or a simple pathology slides, and then can bring out an early detection or very accurate prediction of what is happening far ahead of whether you can recognize it or not. Let me put it in perspective. Let us say I want to screen 1 million women for breast cancer using a mammogram. If one person, or let us say I employ a lakh or 1/10 of this million to screen these images without stopping, working on an 8-day schedule, it could take about a year to screen these images and give an accurate diagnosis without getting tired. First of all, we use a machine learning algorithm to do this. It is phenomenally effective in telling you that yes, without any fatigue, it can pick up the earliest of the changes to tell you, yes, these are the radiographs of these 10 or 4 women which are suspicious of breast cancer. So that means it has removed the rest of the 96 women whose breast images are normal. That means now the radiologist is going to see only 4 out of every 100 images and give an opinion. The beauty is that once the opinion is given, the machine iteratively learns what it has been taught. So it will not commit this mistake again. It will either rule it as definitely cancer or no cancer, or sometimes it's screen. The second one what is Internet of Medical Things only and wearables like smartwatches and sensors which can monitor heart rate, oxygen, blood glucose in real time. And of late, it's used in geriatrics where it can detect a fall much before it happens. Most adults beyond the age of 75 actually don't die of a heart attack or a stroke. They die of a hip fracture. So if the hip is fractured because the bone is weak, the neck of the femur becomes weakened because of lack of blood supply. If you fall, you will break the hip, and that's the end of the story. That means you get bedridden, and it is not very useful to do a hip replacement surgery at time. So you can detect a fall which is likely to happen in the next couple of minutes. So you can predict and warn you, this person is likely to fall. Likewise, you can do, we have seen in what we call the COVID epidemic or pandemic, remote monitoring. Dr. Chauhan was talking to you about GPS systems. But if you if you log into the COVID, it will accurately tell you how many people in the next 1 kilometer area in where you are residing are actually COVID positive. So this happens because of use of the GPS technology. And many of you might be surprised to know that the COVID app was the first app in the world to have been designed like that. No other country has this technology to map and tell you in a pandemic how to pinpoint where that person is. It uses your GPS technology of your mobile phone and tell you, yes, you are in an area where so many people are there. Please don't move out or please move out. So that is how we have remote monitoring. Telemedicine, of course, we all went on to a telemedicine mode. So for morning telemedicine, we would review patients remotely and then order medicines or perform a consultation and finish the entire treatment process. Now you have robotic surgery. Last week, a urologist sitting in Hyderabad operated in Noida on a newborn baby with a mega ureter with an obstruction on the left side. So the robo is docked in there. The robo is remotely connected to the urologist sitting in Hyderabad. So the urologist sitting in Hyderabad is performing this surgery on a newborn baby. So it's almost an instantaneous correction and it was a huge success. This man, this urologist, this week is demonstrating this technique in California. So that means we have moved a long way of not having to have a specialist at every place you want. You don't need that. Indians, of course, are now manufacturing robots by themselves, that is, the robots which operate by themselves. So the moment you touch the robot, it knows who you are, what are your operating skills, how much time you spend on a typical case, what is your maneuvering ability, and what exactly are the steps you are likely to do. It can predict everything because it has learned how you operate as a person. So it is called personalized robotic surgery. So it is personalizing not just for the patient, it is personalizing the robot for the surgeon as well. So different people can sit at the same console, but the console will now adapt itself to the surgeon who is operating. So this is a technology which is developed. Actually, most of you might be surprised to know that one person is from Andhra Pradesh. Okay, this is from Andhra Pradesh. Who went to Oxford, offered the technology to Oxford, but they did not take that. So he came back to India and set up the company.
No, sir.
Okay, mRNA technology. Most of us also have heard about mRNA technology when we knew that we have an mRNA COVID vaccine. Now we have moved away from infectious diseases to manufacturing a vaccine which is specific to individual patients. That means the vaccine, this mRNA vaccine, picks up the epitopes or the antigens which are neoantigens which are present on the cancer cells of that person and teaches the body how to manufacture its own antibodies to fight this cancer. So that mRNA technology once again has come to Hyderabad. So a company called My RNA Vaccine is established last week and soon we will be rolling out the technology to manufacture individual cancer vaccines for patients. Okay. 3D printing, of course, I can now print a trachea if I want to do a tracheectomy for a cancer of the larynx. I can remove the larynx, but before I remove it, I can create the larynx using the MR images from the patient. So I can do a 3D printing. Most of you think the 3D printed one is actually a synthetic model. That means it is containing plastic. No, it need not be plastic at all. I can now 3D model print using biological tissue. That means I can use cartilage, I can use blood vessels, I can use epithelium, I can use nerves, anything I want in the same sequence as they were present in the organ which I am going to remove to integrate. That means I can use the patient's own cells, throw them in the system. So I have a pool of cells which form the blood vessels, another pool of cells which form the cartilage, another pool which forms the mucous membrane and skin. And I can print a full ear or a full throat with living cells. So 3D printing is no longer meant for purely a scaffold. So that concept is gone. I can 3D print an organ. So I can actually 3D print a whole liver. So I don't have to worry about making that, making a new liver for or taking a liver from a living donor. No, this doesn't need to be at all. We now have extended reality, virtual reality, artificial reality, anything you want for teaching purposes. So it is phenomenally easy to train a surgeon or a ANM for that matter into doing what is likely to be done in the field or in the OT. So I can plan. That means if you go to the GSL Medical College, you will have a mannequin which is actually a complete replica of all the anatomical variations in the atlases given. So I can feed the MR images to the mannequin. Now the mannequin will be a digital twin of the person whom I am going to operate upon tomorrow. So I can now practice on this mannequin what about the surgery I am going to do tomorrow. So how did this become a digital twin? It has all the anatomical variations. Plus, I have already input the MR defect images or the CT scan into this system, and now it turns into the patient on whom I am going to operate. So it will bleed, it will drop its blood pressure, it may have a cardiac arrest on this artificial table today so that I avoid them tomorrow morning. So everything about the patient can be fed into this mannequin or the digital twin as we call it, as we try to replicate the surgical steps which are going to be done. And of course, most of you are familiar with the DPDP Act, which got approved in 2023, and the rules were framed in 2025. That is, India now has its own personal data, digital personal data act, protection act in India, which is quite different or quite similar to in some ways to the HIPAA Act of United States. So we have a way of using this technology for broader population health initiatives. Then we have wearable sensors. A patient with a heart condition uses a smartwatch to perform an ECG and alert their doctor to the irregularity. In fact, the smartwatch can now be linked to an implanted machine which can give an electrical shock and terminate the entire arrhythmia. So it is possible that I have transmitted this ECG to the doctor. The doctor who is remotely sitting and monitoring my ECG recognizes this is a ventricular tachycardia. It will be fatal in the next 30 seconds, and he can initiate a remote operation via the cell phone in my hand, giving a command to the implanted defibrillator to give a DC shock from the defibrillator to terminate the ventricular tachycardia. In fact, you can put it into an auto loop that the system which I have implanted now can recognize by itself a ventricular tachycardia and terminate it also. So such systems are also now available. Some more wearable sensors I will show you in the next picture. They are in surgery. I have already told you 3D navigation data, whichever the CT scans and MRIs and PET scans we have used, the same which can be used now for that. A smart bandage is something which tells the surgeon that the wound is healing, there is no infection, it is going to heal perfectly well, or it is not going to heal, it is got infected. So it can actually trigger a response and tell the nurse this person's wound is actually not healing. So this is a virtual reality training program. This of course is a wearable where it is monitoring the glucose of the patient 24 hours, 365 days. It can monitor the glucose of the person and it can adjust the dose of insulin accordingly through an implantable pump. This is actually a 3D printing of an ear. So this patient is going to lose an ear or has lost an ear. So it's now 3D printing. This 3D printing model is actually not a model of plastic. It is a bionic model. That means it actually uses human tissue to make the ears. So these were listed as the top 10 technological advances in medicine in 2025 and 26. So how did this happen? Of course, through genetic engineering. You can use biotechnology for manipulating an organism's gene. And of course, you can use a CRISPR-Cas9 to edit and remove and reinsert a healthy gene. So we have already shown this to happen in sickle cell anemia. Within India also we have shown this to happen. So it will be possible where you have possibly a single nucleotide polymorphism which is happening, which is actually going to be a detrimental to the health of the person. So you can offer into those genetic disorders a potential cure. Second, of course, systems from molecular biology. You understand what is the molecular basis of disease. That means what is the switch which triggered the cancer. And if I put off the switch, can I make this tumor disappear? Yes, that is what we call tyrosine kinase inhibitors. They act as small molecular switches. They are very small molecules, but can enter into the cell, act at the level of the human chromosome, and switch off whatever is triggering this change. A large amount of this comes from the integration of two different subsets of one is biology, the second is informatics. The amount of information you have is phenomenal. If you do a microarray experiment, some of you may know that the amount of information you get is phenomenal. But it is important to understand that you need to integrate it with biology. Let me give you an example. Let us say a woman is sleeping in Voltaire station with her child very peacefully through the night. Any number of trains come and go, any number of hawkers scream at the top of their voice. It doesn't make any difference to her. She won't wake up. But the moment her own child cries, she will wake up. Did you understand what happened? This is called a recognition pattern which is imprinted into our mind. Or let me put it the other way around. If I give you 10 million, that is 1 crore pictures of women, and ask you to pick your own mother from those pictures, you are 100% likely to do it. There will not be any error whatsoever in doing it. This is because the brain is programmed like that to parallel process to look at very subtle clues in the differences between the faces portrayed there to do it. Well, of course, it is happening. We know that it is happening because you have a digiatra. So you don't have to show any more a body pass. It looks at your face, identifies that you are going to board so and so flight, and then lets you through the security. What else do you need? That means you know that within India, it is possible to digitally image the face to be recognized as a person. Yes, it is possible. So that is bioinformatics, but you can do it at a very large level as well. So amount of information which can come from and the noise which you need to eliminate is phenomenally high. So it is important for us to use in bioinformatics to filter out what is the data which is likely to be useful, what is the data which is purely noise, and what is the data which is not at all useful to us. So we use what you call next generation sequencing to look at those changes in the cell which can determine whether this disease is from a particular chromosomal error. The chromosomal error, of course, can be you are born with the chromosomal error which caused the disease or which can cause the disease, or you acquired the chromosomal error later, which is typically the case, and then you have a next generation sequencing, identifying it very precisely. You don't have to do the whole genome project like the human genome project, but you can target whatever you want to look for a disease where you have a treatment available. That means if I am looking at a lung cancer, I will first look at whether this lung cancer is a squamous carcinoma or an adenocarcinoma. If it is squamous carcinoma, I won't look for any targets to or small molecules to use for the treatment. If it is an adenocarcinoma, I don't want to subclassify whether it's an EGFR mutation positive, an ALK mutation positive, or a ROS1 mutation positive. Within the EGFR mutation, there are roughly another 24 different mutations with the different levels of responsiveness to a drug or a class of drugs. So I can subclassify and pinpoint and say this person has this mutation and he will respond to this treatment. I can go to the extent of saying there are some co-mutations which are going to be very inimical to the effect of this drug or efficacy of this drug. So watch out. This drug alone may not be sufficient. I can stretch my neck and say, over the next 4.5 years, this patient is likely to develop a second or a third mutation for which you require a different type of treatment. That means you can now use it for prognostication and for predicting response to a treatment which is available. Is that all? No. You can go a step further and say, I can design using bioinformatic tools, using AI, a drug which will now talk with that what is now the mutation which has occurred. So I treat a patient of chronic myeloid leukemia. Imagine if the first generation of tyrosine kinase inhibitor, he develops a resistance. I will see what is the resistance because of. Typically, it will be a T37155I mutation. So I will add a drug or change the drug to a molecule which will work on a imatinib resistant drug mutation. So it is quite possible for us to use bioinformatic tools to our advantage to tailor the treatment to patient on an ongoing basis. So just like how your tailor takes your measurement each time you go to him, okay, he can't stitch the same pant or the shirt as when you are 10 years old and when you are 40 years old. You might have put a couple of tires around your waist. So it is important for you to understand that you need to look afresh at the disease each time the disease stops responding to treatment or comes back as a relapse. So when it comes back as a relapse, you need to look at it afresh. So what we need to do, can we bring it to the diagnostic lab? Yes, of course we can bring it to the diagnostic lab. Now everything is reduced to a desktop analyzer. Anything and everything can be miniaturized and reduced to a desktop analyzer by using what we did in the lab as a PCR technique now is available as a single cartridge. I can put the soup is already available in the cartridge. All that they need to do is to add a biological sample, and in about 90 minutes, I will get the entire PCR result done. Oh yes, whatever is the gene I am looking for, is it mutated or not? I can give the result in just about an hour's time. Yes, it is possible to do that. Well, we always talked about the tumor or the disease, but what about the environment in which this disease occurred? A neurological syndrome, a rheumatological syndrome like SLE, rheumatoid arthritis, or let us say a COVID occurred or HIV occurred. Most of you might be knowing that in certain individuals it is impossible for the human immunodeficiency virus to enter the lymphocytes. So they are born with that mutation and they are immune to HIV infection. So can I use this technology or can I use the body's own defense system which is lying twice and there like a Sammohanastram, and when the Sammohanastram effect has been removed, let us see whether we can now ask the body to recognize which is dying dormant, recognize the tumor within the body and start killing it. Yes, we can do it. That is what we are doing. when we do a CAR T cell therapy, I take out your T lymphocytes, natural killer cells, outside your body, re-educate them, expose them to the tumor antigen, allow them to develop an immunity. Then I expand them to a couple of million cells outside in a petri dish or a flask, and then reinfuse them back into your body. They are neuron T cells, so there's nothing like rejection. It is not like doing an allogeneic transplantation. They are neuron T lymphocytes. They will definitely be coming into your body, and then now since they have been trying to recognize this tumor, the exhausted CAR T cell now becomes a very active CAR T cell and can recognize and recruit additional cells and mechanisms to start killing the tumor. And we can now demonstrate how long the CAR T cell lies within the body. Well, this is what we call as radiomics or precision treatment. Now, for everything, I wanted a biopsy. I wanted some tissue to study. So there is enough information available of thousands of such tissues from thousands of locations within the body from across the globe. Can I integrate it with the radiological features of that tumor? We using artificial intelligence and machine learning, and can I now predict that this lump here, what is this lump? So in future, it will be possible to demonstrate that, for example, at the present moment, if I see a patient, a woman with endometrial carcinoma, using a radiomics data, which will be available to me in 24 hours, I can predict without having done a biopsy for that woman. I can predict that this is going to be an adenocarcinoma of the endometrium. This is going to be the molecular structure of that tumor. Whatever it is, whether it is pole mutated or P53 mutated or plainly wild type, I can also predict whether this woman is going to have a metastasis to the regional lymph nodes or not. So I can tell the surgeon, all that you need to do is just remove the uterus, don't touch the lymph nodes at all. This woman is not going to have nodal metastasis. So all this
is it based on the texture or a shape?
All of them, sir. So I have given you what are all the features which we are going to look. All the 6 features we are going to look. Facial features we are going to look. That means we are going to construct the histograms. We are going to look at the texture. We are going to look at their position. We are going to look at their shape and size as well. So all of it we are going to look at it and then integrate it with the genomic data. Whatever was genomic data already available, you integrate in the same patient the genomic data, and you can use this as the radiogenomics data. I was just telling sir a few minutes back that we got the ANR grant for this 15 crores to work with IIT Hyderabad. So very glad that this was the original work which we did it from the human atlas. So the human tumor atlas already has this data. So the radiomics team there developed a method, a model to predict what is the type of brain tumor that this patient is like to have without doing a biopsy. What is its histology going to be? How long is this patient going to survive with surgery alone, with radiation, addition of radiation and with addition of chemotherapy? Yes, all of it is now possible. We now want to extend to other tumors which can occur in the body, like a lung cancer, a uterine cancer, a cervical cancer, an ovarian cancer, and some pediatric cancers as well. So that is the type of data which you can generate if you integrate many disciplines into one. So what is important is not to work in isolation. You need to collaborate with those people who know some other aspect of your work. So this is what I said. So what is the amount of blood supply it is receiving? Amount of necrosis. These pale areas are necrosis. Hypodense halo we call it. And then, as you rightly said, sir, texture heterogeneity we detect. And then the whole thing is used integrate it with a gene reassignment models. So what is the genetic partition we have? So we are going to do a whole genome sequencing for all these patients, including an exome and intronic sequencing, and then do it. Well, the last, of course, most of you might be very familiar in the engineering colleges, what we call a lab on a chip. So it is something with possibly, it's not a big machine which is sitting there and I feel it, but this is an individual. We have something like this when you do a pregnancy test. Most of you can buy a small strip, like a glucose strip, urine glucose strip. You just dip it and then it will tell you you are pregnant, you are not pregnant. Simple, straightforward. Similarly, it can tell you this is your glucose level. Similarly, but that is a very simple biochemical method. But here is a lab which is on a chip. So is it feasible? Yes, of course it is feasible. So you can use microfluidics to drive many things into the lab, and you can, the chip itself contains all the necessary reagents. Is this happening now? Yes, it is happening. For example, I can go to the intensive care unit, I can take a drop of blood, and in the next 5 seconds, I can tell the entire biochemistry, entire 26 parameters which are necessary for clinical pathology and biochemistry to be read. Yes, I can do it. Yes, it is happening. But we want to see if we can move it for a disease diagnosis. We are now running a small project with IIT Hyderabad using aptamer coated with sensors, through which we will use micro voltage routing to see if there is a change when there is a binding and when there is no binding. So you can actually detect it at a little less than femtomolar concentration. So that means it is unbelievably sensitive, but whether it is specific or not needs to be proven. So we know that it is sensitive. We are yet to go to see whether it is very specific or not. So all of that can be integrated onto a small chip, and all that you require is to have a chip, and in 10 seconds you can get the entire information once there. Why do we want to do all this? Of course, the patient medical benefits, improved diagnostics, and personalizing treatment. By personalizing treatment, we mean that every patient is, if you go to a homeopathic physician with the same complaints and the same diagnosis, no two people will get the same drug. I hope you understand what I am saying. That the homeopath has recognized long back that this person loves to take a hot water bath on a cold day. This person loves to take a cold water bath on a hot day. He sleeps here and he eats this, he eats that. So he has a different personality trait which is meant like that. So yes, of course, that is personalizing treatment, but on a different note, it is tailored to what your specific condition is in your own milieu. That means what is your age, what is your gender, what is your race, what is your pharmacodynamics, how are you likely to handle the drug. All those things need to be important, and you can create a personalized treatment plan which we expect leads to a better outcome and fewer side effects. And of course, you don't have to be in a city if you have a lab on a chip. The Karnataka government experiment already proved that yes, you can have a better access to care. You can take these machines anywhere. They are tropicalized. You don't have to import them, so they will still work at 45 degrees centigrade in the midsummer as well. And you can use it as a diagnostic tool to bring quality healthcare to remote or underserved areas with limited medical resources. Yes, so for a country like ours, it is very useful. We did a similar thing with about 10,000 images with what we call a smart scope for cervical cancer screening. So the scope can be used by an untrained human being. That means a community health worker or less than that, somebody who's passed 10th class can actually be trained to use the scope. The scope uses the information after you apply iodine and acetic acid, and it will tell you everything is fine this woman, call her back after 5 years. Something appears to be wrong, please refer her to a specialist. This is a wrong, this is definitely a diagnosis of in situ carcinoma. This woman requires a colposcopy. So that type of smart scope technology has been developed in India, and so they can be used remotely. You don't have to go there to use it at all. And of course, you can use it for enhanced patient monitoring, all through, you can use health trackers and AI algorithms that can enable continuous real-time monitoring of the patient's vital signs. And they are very useful for chronic conditions like diabetes, hypertension, heart disease, stroke, dyslipidemias, liver failure, etc., etc. So, a last few slides on technology for public health. Yes, some of these have been attributed by our chief guest, Professor Johan. Yes, you can use technology very conveniently for monitoring epidemics and pandemics. This is very important for us to understand that you can monitor what are actually people talking on in WhatsApp. So what is their fear? Now everybody seems to be worried about fat in the liver, NASH as we call it, non-alcoholic fatty liver. So that is, you can compile the data and use health system strengthening, and let us say I want to move a million vaccines to polio vaccines to the remote areas of Assam. From peak to peak, the actual flying distance will be 30 kilometers, but it will take you from that peak to come up to this peak about 38 hours by road. So the vaccine needs to travel by road to reach that village or to vaccinate that child who is at least 10 years or below that. So you can vaccinate, monitor the vaccine using a chip inside the vaccine carrier. That means you can have a refrigerated vaccine carrier with a GPS in it, which can be remotely monitored. What is the temperature? How long was it kept open? How many doses have been taken off? How many doses are remaining there? Everything can be seen by very remotely. So we can do any amount of surveillance and awareness from there, and we can actually modify the behavior of people using all this technology. That means I can, just like what we call story mills. So how you create WhatsApp stories which are fake or which actually are very detrimental to the society. That is gossiping. So you can do a epidemiologic surveillance, health resource allocation, emergency response planning. Sometime back, most of you received, I think 3 days back, at 11:15 a.m. in the morning, a loud sound on your mobile phone. That is a methodology of emergency response planning. If there is an earthquake, if there is a natural disaster, what to do? Community health planning and health trend analysis. How are people going to live? So I can actually monitor what children are eating, school children are eating. When I was a teenager, the incidence of obesity in adolescents was 5% in a city. Do you know what it is now? It is 85%. 85% of the children are obese. That means the mothers are just force feeding them as they read through Narayana and Chaitanya, working for some IIT or medical course. They are force feeding them. And where is that food coming from? You have Zomato, you have got Swiggy. You don't have to do anything at home. So nobody is there at home to prepare food for you. So the next stop to have food is next to your house, and they will deliver it to your house at any time of the day. You go at midnight, you get midnight biryani. Okay. So eating food has become a fad, and that can be monitored. That type of behavior can be monitored, and this is the type of digital technologies which we use for COVID. We use all these technologies, smartphone apps, security and privacy preserving technologies, social media and ordering searches. What did you buy? Did you buy a paracetamol? Did you buy something else? Did you buy something? So digital diagnostics and genomics, and of course, all the visualization tools should be available for the state to monitor the health of the patient. So, in a gist, I have given you what is now possible using technology in healthcare, and I thank you for your patient hearing.
Sir, I'm Dr. Srinivas Kumar, Professor of Electronics and Communication Engineering. Rather, with the reference of Professor B.N. Dikshitru, when you were there as the chairman of Andhra Pradesh Academy of Sciences, you made me a fellow of Andhra Pradesh Academy of Sciences. Thank you. Sir, not only that, I met you a number of times in connection with my family members who are the cancer patients. And one of the problems which I face personally in the year 2010, Omega Hospital, Dr. Mohan Vansi, Dr. P.S. Bharat, both have done the treatment to my mother. And first they identified that there is a tumor, but they could not identify whether it's a malignant or a benign. Then they have done a biopsy. And the biopsy is sent for the lab. And it took 10 days time or more than 1 week time to get the biopsy. By the time, the cancer from stage 3 it is increased to the stage 4.
That is phenomenally rare, sir. Let me put it very bluntly. If I see a lung cancer in stage 1 today, how long do you think it would have been there?
But they were telling
It would have started some 4 to 14 years back. It has not started yesterday. It is not possible. Professor Mohanrao will bear with me. It doesn't happen overnight. It can happen in acute leukemias.
So without waiting for that time, without getting the report of biopsy, can we identify based on the texture, based on the shape?
Yes, that is what radiogenomics attempts to do.
Yes.
Radiomics and
In such
genomics.
case, will it be possible for you to give some images related to the carcinoma, related to the Hodgkin lymphoma, related to the non-Hodgkin lymphoma, different
Yes, you are right.
if you are able to
one of the projects which we are planning to do is to distinguish
different
whether
cancers.
it is cancer or not.
Yes, cancer or not, if it is a cancer.
It is a cancer of that organ as it comes from somewhere else.
Yes.
Third, if it's a primary tumor of that area or a metastatic tumor, what are its molecular characteristics? All of that you can use that information.
That image processing. Image processing.
Right.
And based on the different cancers may have different textures.
Yes.
Different cancers may have different shapes and different descriptors.
Yes, you are right.
And based on the descriptors, shape and texture, we will try to identify what is the type of the cancer from the.
We are already doing it for breast lumps.
Not only breast, anywhere.
Let us take the breast. Out of 100 women I see with a lump or without a lump, in those with a lump, 9 out of 10 will not be cancer. They are very benign tumors, like retroadenoma, fibroadenosis, or an intrarectal papilloma. They are not cancers at all. They will never become cancer also. Right? Only in 1% we will have a 1%. We will have a doubt whether it could be a cancer.
Or TB.
But I can no, sir. You can make sure the certain diagnosis that it is a cancer or not in a mammogram. So if it's a mammographically, we will grade it is called BIRADS grading. It's a radiological grading. We are uncertain if it is 1. If it is 0, we are sure there is no cancer. If it is 2, we will say it is benign. 3, it is probably cancerous.
What is the type of the cancer?
And the type of the cancer.
Yeah.
So I can tell you what is the likely histological diagnosis going to be cancer. But I can't at the moment predict whether it is going to be ER positive, PR positive, or ER negative, PR negative, HER2 positive, HER2 negative. That I can't tell. But if I add that genomic data to the radiomics, it can now predict that without doing a biopsy, this is going to be the histology, this is going to be the molecular classification of the tumor. That is the idea.
Will it be possible to give us some the database of certain different types of cancers?
Yeah, it is possible. That's what we are going to do.
Then we will try to approach you, sir.
Sure. You are more than welcome.
The second point. And today we are having a pacemaker inside. And this pacemaker, they have to remove it, charge it again, place it inside after 5 minutes.
We already have remotely chargeable pacemakers also.
And yes, not only that, our human body movements can also be used to charge the battery.
No need, sir. Just like how you can charge this mobile phone without connecting a charger, that is an RF induction, charging. I can use an RF induction charging to charge a pacemakers will now last about 20 years. So my job will be to recharge it after 20 years only, not now.
Thank you, sir. Thank you, sir. It's time for lunch and it's available for interaction. I request you all, please have lunch and join here sharply by 2 p.m. Thank you.